Welcome all of you. Very nice to see here and send my this monsoon discussion seminar. Also, many students here. So we have 7 talks now. It will not take much time. I think it's very impressive list of talks. First of all, I want to thank Hemant and support for initiating this. And also, is this your first day? First meeting. Welcome. So we'll start with the first presentation. Dr. Srijit from IITM long range forecast of 2022 monsoon. 20 minutes, please. Okay.
Good afternoon to all of you. First of all, I would like to thank the organizer for giving the opportunity for this one. I could not attend the last time also invitation. It came in the month of July, but I could not attend this year. But this time I find time. I'm going to discuss the long range forecast of monsoon 2022. I have the issue. And the outline of my talk is like silent features of monsoon 22, onset and withdrawal of monsoon. Present as we have last year we have changed the strategy for seasonal forecast, verification of long range forecast, and rainfall features for 2022 southwest monsoon, and monthly rainfall and synoptic scale systems, intra-seasonal variation, and significant weather happened during the season, and heavy rainfall event associated with this extreme weather event. And global circulation feature, mainly because larger scale features like ANSO IOD only I am discussing. The silent feature of 2022 monsoon is the southwest monsoon over the country as a whole was above normal. That category 96 to 104. Quantitatively, the forecast is 106% of it is long period average. This year we have changed our normal also. That is based on 1971 to 2020, 87% centimeter of is the climatological value now. During the southwest monsoon season, homogeneous rainfall was above normal over South Peninsula and Central India, and seasonal rainfall is normal over West India and below normal over Northeast India. And in the monthly distribution, if we can see that 92 in the month of June, 117 in July, and 104 and 108 respectively in August and September. The main
2021 or 2022?
2022. Yeah, that is. This is the spatial distribution, subdivision, rainfall distribution. You can see that large deficiency over Indo-Gangetic plain that could not predict in the main climate models. And the seasonal all India daily summer monsoon rainfall, if we can see here. Distribution wise, most of the days we got very good rainfall. However, spatially there are a lot of variations. And if you consider the core monsoon zone region, there is a large deficiency in the end of the July and the beginning of the August, and the end of the August also we have large deficiency, and the excess during the middle of July as well as in the August, and September also we got very good rainfall. And this is a monsoon onset. This is also 2022. Actually, I forgot to change it. You can see that monsoon onset over Kerala happened on 29th of May against normal of 1st June, and southwest monsoon covered the entire country on 2nd July against it is normal date of 8th July. And considering the withdrawal started in 20th September from Gujarat and Rajasthan region, but the normal date is 7th September, and southwest monsoon withdraw from entire country on 27th October, and that is a little delayed this year. And this is the new seasonal prediction strategy we have changed. In that here we are now recently we are started to issue a spatial distribution forecast also, probability forecast also based on multi-model ensemble. And first stage we are issuing in the month of April, and the second stage forecast in the month of end of May, and along with that we are issuing that homogeneous region, as well as we are introduced that 4 monsoon zone region also. We are issuing that forecast nowadays, and every monthly forecast we are issuing every month, like June forecast in the end of May, and like that every month we are issuing that forecast. You can see that first stage forecast we have. This is the spatial distribution, and the updated forecast was given in second panel. I'll go that detailed verification in the later slides. And as most of them are aware of this statistical ensemble forecasting system, that also we are using in our seasonal forecasting. Here that 2 models, one is multiple regression as well as projection for pursuit. This is non-linear model, and finally we are making the forecast. And these are the 13 climate models we are using for multi-model ensemble. That mainly from most of the international standard forecast we are using for the preparation of spatial distribution forecast. This is the schematic diagram of the forecast our MME prediction system. We are analyze the all the model hindcast output, and find out the best model. That best model selected model is used for preparation of the MME. And we are using weighted during the hindcast period for weighting the model. That means a good scale model is giving more weightage. And the monsoon onset forecast for the 2022 southwest monsoon, we have issued the forecast that 27th May the monsoon onset may likely to happen. But on the real, the actual onset date was 29th day, that is within the forecast limit. So the forecasters came correct this year also. This is the verification of summary of the verification of seasonal forecast. In the month of for all India, June to September rainfall, first stage we have issued on 14th April. That is the normal category we have issued. That is 99% of LPA with plus or minus 5. Model error with plus or minus 5 LPA. And actually, is happened is 106. yeah, the updated forecast we have upgrade that our first stage forecast to 103, and that also in the upper limit of the our forecast category, but slightly the forecast is slightly different from our actual observation. And in Northwest India, as far as the homogeneous forecast is concerned, most of the forecast came correct, and we have correctly indicated that Northeast India likely to get less rainfall, and the second stage forecast also we have updated forecast issued in the August also, that also came correct actually. And this is the verification of spatial verification. This is the observed category. You can see in the first you can see the large deficiency we have observed over the Gangetic foothills of Himalaya. That is not correctly indicated in the other model, but above normal rainfall in the many regions in the first stage forecast it is came correct. It's a second updated forecast also it is indicated that correctly. But overall the forecast is matching with the observation. But this is the every month we are issuing that spatial probability forecast also. You can see that observed category for June, it is many regions which have correctly indicated, but Northeast it was not came correct, and the Central India it is okay, but still the monthly forecast we have to work more on that. And the main, we have analyzed the La Nina and IOD composite. If you see that similar features you can see during the June. This is the June anomaly, and this is the composite. So there is a well correlation between IOD as well as La Nina composite. And verification of July month forecast is given here. They observed a large deficiency over the entire Northeast India as well as the foothills of India, Himalaya. But Northeast India, though most of the models are indicated, but for MME also it is indicating that Bihar it is okay, but other UP and East UP and West UP we could not get that. The rainfall, observed rainfall feature. The Central India region, Central Indian region also, it is almost in the as forecasted, we got the observed pattern. And in the August month forecast also, there are a lot of variations in the forecast as well as the observed rainfall pattern. But the main thing is that South Peninsula, it is some area it is came correct, but and in Northwest some areas of the Central India also we got matched, but the Northeast India deficiency we have correctly indicated, but still there are large deviation in the forecast. The main factors which for good rainfall in the some region mainly because of the La Nina condition I can attribute, and MJO strength was weak. That is mainly during, but some days we are in the favorable phase, and there are a lot of monsoon depression formed. There are 4 depression formed in the month of August. That have to get many region very good rainfall. And the low pressure system days also, it is more than it is climatological value that we got 19 against it is a normal value of 16.3. And September rainfall verification, that is this is better than the other months, but correctly indicated that Central India and Northeast India deficiency. Even South Peninsula also some region we have correctly indicated. And nowadays we are issuing that temperature forecast also Tmax or Tmax. This is the verification of that minimum and maximum temperature for the September. You can see that temperature forecast is matching well with the observation. And similarly, that minimum temperature also we have correctly indicated that above normal is in many regions. That is correctly predicted. And good rainfall activity in the month of September mainly we can attribute to La Nina. And there are three low pressure systems developed over Bay of Bengal, and out of this one system intensified into depression also. You can see that that climatological are almost 3.6, and we got a 3 system. And you can see the number of low pressure system days that is almost normal we got. And during this 2020-22 Southwest monsoon season, there are many extreme, very heavy and extremely rainfall events happen in many parts of the country, mainly over the west coast of India and central India, as well as the south part of northeast, as well as foothills of Himalaya. And you can see that extremely heavy rainfall also we can see that is happening during the different months of the southwest monsoon period. And associated with extreme rainfall, we can see that significant weather events happen in during the 2022 southwest monsoon. You can see that blue color that is indicating that flood event that is mainly affected over northeast India, as well as the along the many areas over the western part of the country, as well as the central regions. These are the loss of life due to the extreme weather event happened during this monsoon season. You can see that Odisha, you can see heat wave also affected, and you can notice that nowadays this thunderstorm activity, death due to thunderstorm activity is more during the monsoon season. This year it is happening around the region in the eastern part of the country, but last year it has happened mainly over the Madhya Pradesh region. Actually, this is there are if we can see the trend of this loss of life due to this lightning or thunderstorm related, that is increasing by 60%. As in the other case that so tropical cyclone and drastically we reduce that loss of life. These are the rainfall. Okay. These are the statistics. I am not going into detail. But this slide is for future reference you can use. And monthly observed rainfall pattern. This is the subdivision wise rainfall distribution for each month, and this is the actual rainfall in LPA. Can see that in northeast India, that is large deficiency is there. And core monsoon region also, it is very good rainfall we received, and South Peninsula also we got very good rainfall. And if you can see the pattern is for the season almost similar to or La Nina composite. And the synoptic system, as far as the synoptic system, already I have mentioned in the other slide also, but this is summarized slide for this. There are season total, you can see total LPS days is 67 and climatology is 57, and total LPS systems are 11 and climatology it is 13. And this year also that West Pacific typhoon activity also contributed to give very good rainfall in some region. But if you can see that in the month of June as well as the August, That was very less number of system typhoon formed over the West Pacific, and but the July and September many systems formed, and this helped to the formation of low pressure system over the headway. And if we can see that active peak cycle in the first slide also I have mentioned, this is the MJO activity during the 2022 first monsoon. You can see here most of the region, most of the days it is in the week, but over some mainly in the month of June it is in the phase unfavorable phase, but the other July and August also we got in some days that was in the favorable phase. And as far as ENSO IOD is concerned, that La Nina condition was prevailed, and the southern oscillation index is given in the right channel. It also it is indicating that La Nina atmosphere also that pattern is also similar to La Nina condition, and Indian Ocean dipole is negative. Indian Ocean dipole was observed over the Indian Ocean region, and this is the spatial SST pair. But many climate model, including MMCFS, currently indicated that there is a chance for developing of La Nina as well as the negative IOD is correctly indicated. I have summarized my what are the important features of first monsoon in this slide. Mainly, this year good rainfall activity, mainly because of the La Nina as well as the many low pressure systems formed during the monsoon season, and the depression also that is intensified into the depression category also. So it is correctly indicating that the forecast. Forecast for the Thank you, sir. Yeah, but I have press release at the 4 o'clock, so I may leave.
Okay. Maybe we can ask one or two questions.
What is the main reason according to this? You have
Sir, we have to do a lot of analysis in that. Actually, in many climate models also, if you see that for example, not in Indian region, so even the Nepal region, we are issuing that SASCOF outlook also. In that, we have analyzed a similar method for all the countries. In that Nepal region, that is all the models have very good skill, but most of them are indicated above normal rainfall, but a large deficiency observed over that region. But one reason, possible reason may be IOD pattern, negative IOD, that may be possible reason, but we have to do a lot of analysis.
do you have these model outputs? Can you make analysis? Do you store it?
Yeah, on that whatever forecast as well as forecast.
Like to get the data. You get
Yeah.
the data? All are available.
All are available in public space, no sir. Yeah, all whatever MMP data, yeah. Data, whatever we are using in our seasonal prediction, most of the data is all the data is available in public space, Copernicus as well as NMME, and except our MMCFS and including JMA. JMA also now it is available in. Yeah. That also available. Anyway, now we are going to put in our website.
June still I take to normal and normal condition. Congratulations.
Thank you, sir. Actually, we have, frankly speaking, we have a lot of pressure because how we have upgrading that forecast. Then we have very much confidence in that our system. Yeah.
UP is totally dry.
Yeah.
It's still 60 or but
Yeah. But it's,
Sir, what happened? September rainfall was good enough.
yeah,
So if you see, partially that was compensating that area.
this,
I'm not saying, but June, July, August, it was bad. But September, I agree, could not predict. I predicted dry. It was wet. It was opposite.
any questions?
Because 236 people died in Iran because of lightning.
Lightning, yeah. Lightning during this year. The similar incident happened last year in Madhya Pradesh also. Because in July there was large deficiency of rainfall as well as monsoon was weak. At that time, large lightning activity and a lot of people died. Yeah.
Okay. So, thank you, Dr. I think that is a really answer the next question.
Hi. Supposed to be fine. Yeah, no? चाहिए Okay. Yeah. So good afternoon, everyone. So this I will basically deal about this short to medium scale, 1 to 10 days. Okay, not the seasonal scale. So I'll give some food for thought. Already, Srijit has nicely. Huh? What is that? Okay. 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 Yeah. So this is just outline and skip. Yeah. So the model that we will use, please skip for the students. Okay. This is a weather forecast model run globally. Okay. Here everything is written. Run every day, times a day for 10 days. Resolution is 12 kilometer horizontal. Vertical, there are 64 levels. Near real time SST. Okay. So say today's SST we take and we persist for the next 10 days. Keep this in mind. Okay. Because it's not coupled. The atmospheric GC. This is the way everybody is doing, not only us, NSEP also is doing, BMRC also is doing. So it's a global standard, global practice. Then there is a stochastic total tendency perturbation. Don't go into the jargon. This is a technique to generate perturbations. Okay, when we run ensemble, we have to create some, some perturbed initial condition. This is one of the way ECMWF is doing slightly differently. Stochastic is same, but they call it physics, total physics perturbation tendency. So SPPT. Okay, so they are perturbing the physics tendency, physics as well. Here we are not doing that. Okay. Anyway, so this is a difference. Once we do that, so the output is at 0.125 every 6 hourly. Now it is 3 hourly as such. And then the same thing is the ensemble. So this should be kept in mind. I'll just repeat very quickly. Srijit showed this. Actually, this green color actually is red color. Why? Because there is no difference between -18 and -19. You know, so in IMD, color changes from red to green by just 1%. So essentially, this whole area is red. Okay, that is reflected very well in all the individual, June, July, August, and September. But this is actually should be a topic for at least next 1 year. We should brainstorm tremendously because none of the forecast, none of the model could capture this. Question is why? We can argue there is La Nina, there is IOD, whatever it is. But we have many tools. People claims AIML, people claims convection, microphysics, these, that. Do whatever you want. Bring this 4 panels in your table. Okay, this is a challenge. The point is maybe next. Yeah, this is another food for thought. Whole Northeast, it's a huge area. Whole Northeast in a monthly scale showing 50%. It is unthinkable. It has seen one of the worst possible flood. So you will agree. Many people died, cattle, unthinkable. It is as big as Kerala, not less than that. 50% in that region means if you go to the individual stations, I can challenge, you will get to see 20 standard deviation, 20 sigma rainfall. I can bet. Okay, it's not cup of tea of any model. Question why it happened? Again, you can argue many things. IOD, La Nina, this, that, but we have to come with a very specific hypothesis, test it, prove it, and then finally improve it. Okay? No model is able to capture. So these are the two benchmark problems this season has taught us, which I think we should, including in our brainstorming as well. Okay, this is what Sahaj was telling. Look at this. I just can't imagine. It's not that I belong to Gangetic West Bengal, but this particular district did not even get a single, it's outrageous. I just can't imagine, even with this uncertainty of -19, -18, forget it. Still, I mean, whole season did not rain. Now think about the impact, think about the stress, calculate that. Okay, think about the groundwater. So, I just can't imagine. So this whole thing, whatever you see, these greens are red and yellow, and you can see it's raining here. It rained so much. I did not get spinach on Sunday in whole Pasan and Barnet. They say all got spoiled. There's no spinach. You can't get palak. Anyway, look at this. So these peaks, it's interesting. These peaks, basically, these are all very nicely aligned with depression. This comes with one depression, that comes with another depression, this comes with another. So three, basically, we got 4 depression. Okay, one is very small. These 3 are very prominent. It's come. So, So now it comes to model. So again, it's not seasonal. It's weather forecast. Okay, what we have done, take all day 1 forecast. Okay, and take the composite. Take all day 3 forecast of GFS, make the composite. Similarly, day 5. What we are trying to see? We are trying to see whether model for day 1, for day 3, day 5 means 120-hour forecast is able to show this propagation. This is a huge northward propagation, right? This is another one. So these 3 very prominent. So what I find, even in day 5, model is reasonably captured. It's not that bad. So it means, it gives an indication that possibly the synoptic transients in this model is captured, is predicted. Otherwise, we would not have got these, strings. Okay. Question is the same signal. Okay. So this is IMD GPM gridded data. Okay. And this is for this is for season as a whole. We took day 1 forecast. So question is GFS on day 1 forecast, was it showing a lot of rain over this whole region or no? Yes or no? Or is it showing good rain over this time? Or is it showing the right signal as that of observation? What I find 1, 3, 5. Okay, broadly it is good. So after 5 days, it is able to capture the signal. Okay, that again because the transients are captured, to some extent with some skill. Okay, that's why we are getting this figure at least in the weather scale. And okay, what is this? This is something, right?
Month-wise.
Oh, month, yeah. So month-wise, yeah. Sorry. Okay. So here, here the model has screwed up. So in the northeast itself, there is a very finer divide. Okay. This part got heavy, extremely heavy, actually. This part is not, but model is showing all uniform. Okay. Yeah. So okay. Now July, there is no difference. This region did not get it. Okay. And this part, you can check it. So so anomaly signals and
June, day 3.
Yeah, day 3. Yeah. Day 3.
The observation. So northeast.
Yeah, no. So
Blue is
I think he has made
blue is
wrong in color.
Color in grade and blue.
Yes, so actually, yeah, the IMD color he
Opposite.
it is opposite, okay? So you messed up with this.
Oh, this is.
Yeah, sorry. Okay. Yeah. So yeah, that means positive. Okay. So yeah. So now coming to September, for example. So September was the hope for this gangetic plain, as I think Rajgopal was telling. So there is some rain, here. Again, it is ulta. But anyway, so September. Now coming to one of the systematic problem of this model. You see, this is the from the observed rain, observed data, right? What we find, this is the the rain percentage of this 0.25 to 2 centimeter per day. Okay, this is 2 to 6, this is 6 to 10, this is greater than 10 centimeters. So it's really heavy. Okay, from this onward, it's very heavy. You see, there's a lot of grids. They're getting lots of very heavy and this thing. Now, when you come to model, you see, you have to struggle. Where are those grids? You can't find it easily. Okay, whereas you see this lighter rains, the plenty. You don't have to even struggle. You can, for a far distance, you can see it. So this gives a very clear, signal that models are still has a tendency to produce too much of lighter and moderate rain and too little, deeper rain. That's 2 to 6. Yeah, 2 to 6 is high over Myanmar coast and so on and so forth. Okay, not so much about central India. See, it's less. Okay. Yeah, so this is the issue. This is the issue with the model. And that is reflected here as well. You can see if you go towards higher, observation goes high, model goes flat. So this is a systematic problem of many models. Okay, just let me skip this. Okay, come to depression. Okay, as Srijit has already told, number of depression. This is very important. Number of low pressure system days, 23 days. So see, there are just 4 systems. 4 systems giving 23 low pressure system days means what? Means each system sustained for a long time. Okay, and if a system sustained for a long time, then it means it will give you rain, right? Simple as that. But you see, all the tracks, avoiding the gangetic plain. Okay, kind of. So anyway, coming to forecast, broadly, model is capturing the depression tracks. Okay, not 5 day or 6 day or 1 week in advance, but at least 1 or 2 day with a 1 or 2 day lead. I mean, from the time the low pressure is forming, depression is forming, from that, is capturing. Yeah, so that's good. Okay, okay. This is the total number of radiation. It's good. Radiation for this season, June, July, August, September. We have around 50 radiation stations. 50 multiplied 30 should be 1500. So you can see on an average, the 0 UTC. There is no other. I mean, 6 and 18 you cannot expect, but at least 0. At least 0. It is once in a for stations. It has it's broadly 1500. Okay, so that's a good thing. That was not very good earlier. 2021, 2020. It's good. Okay, as a result of that, see, we were actually this is for 2021. Okay, we have a forecast from 2012 to 2021. But we saw everything is dipping. We are very worried where the skill is coming down. 2021, but things have now improved. So again, the skill are increasing. Okay, that's good. So things have improved from 2021, 2022. This is a metric. Don't go into the detail. This is the error metric. If the bar is smaller, it is better. Okay, as simple. So you see, like this is a forecast and observations metric. So whenever so the white is correct, and white color you don't see it because it's the color of only error. Okay, yeah. So let's see, for example, this pink color. It stands for the forecast is dry. Okay, and observation is heavy. Means what? I am missing the heavy rain. Okay, so the error is small. Okay, so it means the model it's not that bad. Okay, that's okay. I don't want to spend a lot of time, but okay, we have compared these with ECMWF and other centers as well. They're all more or less, it's good. Okay, this is our probabilistic skill score for GEFS. Okay, again, I don't have time to go into the detail, but what you can say, see, this is the heavy rain, 6 centimeter rain for day 2 forecast. This is for last year. Okay, you see, by the time we are talking about 50% forecast probability, this red curve is coming out of this cone, means the model is losing its skill. It's meaningless. Okay, that's the conclusion of this. I mean, plot. Yeah. Now, in this year, we find that day 2 is happening in day 3. So we are getting 1 day. Okay, till day 2, it's not happening. So this losing of forecast probability for the very heavy rain category is happening around 50% probability on day 3. So that's a good part. I skip. Now, last discussion, there was some discussion about some case studies. So there are many cases. This is one case, 17th June. You can see also this is the probability for the heavy. Probability is very less for very heavy, extremely heavy, because the for model, this 11 centimeter model doesn't get in a grid. Okay, so anyway, so it shows some probability, and this is a better figure. Srinath is preparing for last 2 years. This is a percentile. This is a probability of percentile, and this is a EFI. EFI is exactly the way ECMWF does. So extreme forecast index, and this you can see. For 95th percentile, and you can see even on day 5th, you can get a signal of more than 75% probability of an extreme. Okay, so this is good for the forecaster. Similarly, it was at the time when depression was crossing, there was heavy rain over Mumbai. The student must know what are these waves. Okay, in spectral model. Okay, I'm not going to the detail. Yeah, similar thing for percentile, probability of percentile, and EFI. So this is very systematic. You can see the heavy extreme forecast towards Pakistan in July. This was getting devastated. Okay. Yeah. So this again for 22nd September. Yeah. So I will skip this. So this is just I plotted. What Srijit was you are showing is from your climate bulletin. Okay, that's. So that is a catch. What they say that is the maximum rain happened in a month on a station. That's the catch. It doesn't tell that how many that you understand. Yeah. So when you do that, how many? Okay, frequency 0 to 5 times it happened, 5 to 10, 10 to 25, more than 25 times this rain happened. Okay, on how many grids? Then we find in August really there are so many grids where 0 to 5 times this rain, which is heavy, actually happened. And interestingly, you can see there are very few over like Gangetic Plain. Okay, so yeah, this we tried something new. It is the frequency, again same thing, but we are telling 75% probability. Okay, wherever rain is exceeding 95th percentile for the model. Okay, and for this figure, sorry, this is my time, I think. Yeah, okay, I cannot take others' time. So anyway, I will skip it. Okay, this is cyclone Citrang that has happened, and you can see this is again a success story because when the cyclone did not even appear in Bay of Bengal, it was showing that there is a tendency it will move in this direction. But when actually the depression formed, you can see this is a this is observation. Okay, and these two are ensemble and deterministic. Okay, yeah. So this has come very correctly. This is the I think last slide. So you have seen the success and failures of GFS, GFS 12 kilometer and so on. So this is a new initiative. We are trying 6 kilometers over the globe. Okay, and this is the the resolution variations. When you see This is one case when the depression was crossing. There's a heavy rain over MP. You can see day 1, day 3, day 5. The model is retaining. The model is able to retain the bulk amount of rain. Where in GFS you see the rain is gradually fading out, gradually decreasing. So it's
So this is because of only your.
no.
Other-
No, here we have changed only the resolution, nothing else.
Nothing else.
Nothing else.
No physics. No
Physics, actually, the physics which we were using in GFS, that physics was partly made for this type of variable resolution creep, which is called scale aware parameterization. Yes. Yeah. Yeah, that verification we are doing. I mean, it could be when we are doing the whole season, we are run. Yeah, so summary. So summary is that GFS forecast skill for 2022 appears to be better than 2021. And GFS forecast captured monsoon depression and also the tropical cyclone with good fidelity. But the models has a tendency of producing more light and rain, which needs improvement. Okay. Skill of GFS probability forecast has improved for monsoon 2022, as I have seen. We have gained 1 day. And the forecast of Citrang was good. And the new development is happening. I'll stop. Yes, thank you. Any question?
Thank you for that. Yeah, you can sign.
Yes, I gave alarm in my.
Yeah. So one question,
Yes.
if you look at NCMRW of,
Yeah, I mean, not in this detail, but broadly, because we are in touch with Raghu. Yeah, they also 12 kilometers. So, see, there is a recent paper Raghu published in Journal of Earth System Science, and he used GFS, IFS, and 4 or 5 models. So broadly, they all come very close in skill-wise. Okay. There can be differences in depression tracks or in cyclone tracks. Minor difference will be there, but you cannot get a very large difference of skill or anything. So that is our last 4 or 5 years of experience. Yeah.
They are also got.
Yeah, depression. Yeah, they must be getting. Yeah, because they also kept on. I mean, communicating to IMD. So. Yeah.
So the radius on the data.
Radius on, yeah, I think so, because see, in 2021 we very clearly saw that the skill slightly came down. Now radiation become healthy numbers. I think that has helped the initial conditions and the dividends we are getting in the forecast. I think so. But if you can make it 4 times a day, things will be even more beautiful. Yes.
GFS is very expensive. GFS.
Yeah, expensive. Correct.
GFS. And I will ask you whether we can manage with GFS.
No. Come again. What do you say?
You require ensemble system.
Yeah, definitely you require. Other one?
For that purpose,
No, that's a huge purpose. That's a huge purpose. See, for example, when the cyclone was coming, okay, let me. No, you cannot selectively. You will run some ensemble for cyclone, deterministic for depression. Tomorrow cyclone will happen, day after tomorrow. You cannot do like that, right? The operational center cannot make a strategy. Today I will cook food in one way, in gas, tomorrow in coal. You can't do that.
You showed the day 1, day 3, day 5.
Yes.
But you are making 10-day forecast.
Yeah, correct. See, yeah. No, I can show you, because beyond day 7, the forecast really goes very low. Okay. Yeah. So that's why I don't show. So we are normally, so one of our target using the 6 kilometers is that whether some of the skill can improve using this resolution. Can we increase it to 6 days or 7 days? So weather forecast beyond 5-6 days with the uncoupled version, it's really difficult. Yeah.
Because of consistent SST.
Yeah.
I have one question.
Yes, please.
22, you said that skill was better.
Yeah.
Because of IC. It could be also.
Not because of IC alone, but
So
one
what
of
is the
them.
reason?
One of them. Yeah.
So it could be also large scale, you have a favorable large scale.
Could be,
for
could be.
La Nina.
Yeah,
So.
could be. But the problem is, even if you give me a very good large scale and you give me a very bad initial conditions, I can guarantee forecast will be
Yeah,
very
that's
bad.
the extreme. But my point was
Okay.
that some year, for example, we have not very good signal. So that year
It could
may
be, it could be, it could be.
challenging.
Yeah, yeah, it could be. See, many times I have in last 5 years, so the depression track was not good. And this time we are finding depression track come very correctly. That could be a large scale support, you know. Yeah.
So we actually will go to the.
Yeah.
Thank you. Thank you.
Yeah, please. Shilan.
Good that you showed some case studies.
Yeah.
But these are all success stories, right? Is there any failure stories?
Yeah, yeah, failure stories also are there. See,
See,
failure stories, no, this figure what I showed you, is I will tell you. Where is that? Yeah, this is a, very prominent failure story. It tells the whole season in one slide, because, you see here, the model is not capturing 6 to 10 and greater than 10. Here is your observation. Okay. And this head-to-tail convection, no model capture. That's a tremendous problem till today. You know.
Actually,
Yeah.
you see seasonal.
mainly for
Extended.
Whatever. I'm telling you, this slide. Yeah, yeah. So this slide is a. So we take this as our benchmark failure slide. Okay.
No, I think.
When I get this 6 to 10.
purpose of asking
Yeah.
failure stories, sir.
Yes.
People say that we learn from failures, but here you don't learn anything.
No, if we have no. See, no. See, if no. Point is, if I start demonstrating my learning here, you understand, then this discussion will go up to 5 o'clock. Only example, and I will finish. The point that we have learned, that is only visible that the ensemble forecast has gained by 1 day. That's what we have learned. So we are learning every day. We are learning from 2022 and earlier season also, but I don't keep the summary here, story here.
Thank you, Partha.
Yes, thank you.
Yes.
I finished in time for discussion.
Yes, good afternoon, everybody. So I will give what was the seasonal prediction model, like the MMCFS predicted for summer this season, and then what actually we did in observation, and I will try to see some maybe some causes what happened in the season. So what is in the, I didn't include anything new. That's all shown by the previous two presentations. What they give outlook for the summer season as a whole. So if you see February, I see from our first presentation, we are at JJ, June, 3-month average, June, July, August, September, and the JJS together. So, and this is for March I see. So 3 long lead I see, February, March, and April.
How many members?
Sir?
How many members?
So this is IMD's run only. From IMD website, right? Okay. So all the ICs give on an average increased rainfall over the monsoon region for the season as a whole. JJS season as a whole, it gives increased rainfall. So this is the latest from IMD LRF report for the based on June IC. So what they showed is that July, August, September has increased rainfall over this region, and the SST pattern is like a La Nina like pattern in the Pacific, and something like a negative IOD in the Indian Ocean, and there is a warm pattern in the Atlantic. That's what the model predicted for the July, August, September season from the June IC. So it's an immediate IC to get this pattern, and this is the next season, August, September, October. Also, that's a liner-like pattern is persisting still there, and that dipole-like pattern is also there in the Indian Ocean. So this is was the forecast.
Pretty good, right? July, August, September.
July, August, September, yeah, but as Dr. Sritan Partha was telling, this extension is not there.
But that's a broad signal is there.
Yeah, broad signal is there. Yeah, broad signal is there because it's a June IC. It's a June IC. It's a June IC. This is only June IC. So the previous one I showed is this. This is the long lead ICs. Here also we have that increased patterns there, but may not be the spatial pattern proper. But all India it is showing increased pattern for the all ICs. So CFS predicted increased rainfall over this. This is a June IC. If you see month wise. So what is happened is July. This is a July pattern, and then this green. This blue shade is the increased rainfall. So we have increased rainfall over June, July, August, and September. Just 3 months we have increased rainfall is shown by the CFS V2. And the NINO 3.4 index, if you see, it is showing a weak lana-like pattern throughout the period. And also, if you see DMI index, also we are seeing a weak negative IOD-like pattern is is predicted by the model for the rest of the season. So that is what happened with the model. Then if you see other models also, if you see ECMWF forecast is based on the system 5 and it is based on July forecast, you can see the same kind of situation. There's a weak lana-like pattern in the Pacific and then negative IOD-like pattern in the Indian Ocean, and the resultant rainfall we got it like a somewhat increased rainfall over the Indian land region extending towards this. But we are getting this kind of pattern and a dipole-like rainfall pattern over the Indian Ocean also. So this is a pattern ECMWF predicted with the system 5, and this is IRI from the website. IRI multi-model also predicted. We have some because they have land rainfall only they have given. So some increased rainfall over the land region, and what they predict is that is a La Nina like pattern around 1 degree Celsius anomalies are attaining in the month of July, August, that period. Many of the models predicted that same way, and their probability also shows that it's and so La Nina has the most probability up to the month of October, November, December. La Nina probability is more. This is what IRI models predicted for the season. And if you see the Bureau of Meteorology Australia forecast for IOD, so they also predicted negative part of the IOD as it's not that much weak. They predicted negative IOD from August, September, October, like that. That's the prediction. So if you see a multimodal ensemble from the NMM website, North American Multimodal and Experiment Project website, so there La Nina is somewhat more developed than other they predicted, and there is a negative dipole also in the Indian Ocean region, and the resultant rainfall is increased rainfall over the monsoon region and a dipole like rainfall pattern in the Indian Ocean region. So if you see, this is our May IC plume for the NINO 3.4 forecast. Here also we have somewhat like a negative means La Nina like pattern with the probability of in the June, July, August, September, up to that probability of more than 50% probability for the existence of a La Nina. So this is what we got, and this is the CFS V3 RAM because the figure is provided by Dibesh. He is not here today, so he give me the figure.
This is totally opposite. You see?
Yeah, the pattern is yes, pattern. No? Sorry, you are telling about the rainfall pattern. Yeah, rainfall pattern is totally opposite because as observation, as we know from the previous two speakers, here is a reduced rainfall for the observation, but the model got the increased rainfall over that.
June initial condition, we should check whether.
This is CFS V3.
CFS V3 with the April IC.
Previous one was the.
Previous one was IMD's that MMCFS only.
No,
V2.
T382.
T382.
So that is different from.
No, this is also T382. But what they have done is that he has made some change with the ocean model is MOM6. And then semi-Lagrangian GFS code he is doing, and coupler he has some change in the coupler. So this is like a new run, this experimental way Devesh is doing.
Other one was.
Yeah, because
Is the April IC?
yeah,
No, which IC?
this is April IC. With the April IC he is running.
You don't have June IC for this?
No, I have to check with him because he is doing just like the development of the thing. So I don't think he might have every IC he is running. So actually, sir, the problem with this, you see, sir, this is the, because if you see the SST pattern, sir, this is the, here we have a increased SST and the La Nina like a negative SST pattern. So that's why I think this pattern is coming for the model. Because here, if I don't have winds, because if I plot winds, there will be diverging winds will be coming from this region to the Indian land region. And here is a divergent wind to this region. So we expect should be negative rainfall in this region and we should have a positive rainfall as the wind pattern. If you see with this, I don't have the wind pattern, but I think that will be the pattern the model is giving.
CFS V3 and the earlier one.
V2.
3382. You have a picture there, fine.
You have April IC of CFS V2?
Yeah. This one. Yeah, this one.
Yeah, that can be continued.
Yeah, this is the April IC.
Is also positive.
Here, India is positive.
Yeah, model gives full positive rainfall because it's a La Nina pattern.
June IC is better.
Here also.
Sir, here is this is the positive rainfall.
It's positive in the negative in the north.
No.
It's also positive, sir. This is the problem. Figure will be making by different people. So, sir, sorry, sir. This is also positive, sir. This color scale is positive.
Okay. Yeah.
So all the models give positive rainfall over the northeastern region.
Yeah, but anyway, it is not correct.
It's not correct. Yeah. Because if you see the, because the pattern is, yeah, because this is the, as due to this convergence, I think there is a negative rainfall here.
But I thought your June IC was doing.
Yes, because it's immediate IC. So June, no, he didn't, no, didn't, I think we don't have the run. Yeah, because this one actually, this is.
June IC high current we have not filled.
This is the only thing with the 30-year run we have.
Okay, fine. Anyway.
So this is what, there is some differences there, but this is what, as if we see the Elino SST patterns, which is all the models are capturing it, almost all the way, because this is the like a La Nina pattern and then the negative IOD is getting in the model. So, due to all these outputs, because IMD predicted the 96 to 41.40% in their first report, and the La Nina condition is prevailing and the negative IOD condition. That's what is predicted for this 2022 year. Then what will be the observed features in the season as a whole? You will see. So this is what maybe already shown by stages. So this is the seasonal mean. So we have decreased rainfall over this region, and this is the month-wise distribution. This I took from the IMD's end of the season report 2022. So what they have given is that June is minus 8% deficit, but almost all the areas we have more deficit areas, and then July is a surplus with 17%, and August 3%, and September we have 8%. So it's a season as a whole we have 6% as a surplus. So models also produce surplus as a season whole, but this pattern, as we discussed now, this pattern is not there in the models. So this is what we got. So this is a work Ankur is doing at present. So he's doing about the monthly one. So he give this one. So what he is telling is that if a small deficit in June is always end up in the normal and above normal rainfall. If you see like a statistical analysis, what he did. So he has done all these years with IOD, negative IOD, positive IOD, negative IOD, neutral conditions. So he has done some analysis and hopefully he will publish it very soon. So we will get the more result from this. Almost all negative IOD during JJ result in normal or excess monsoon. That is what the statistically it is showing. So this year also like that. So this is from IRI website. This is a plot of June, August rainfall and SST. So we can see June to August. This is the pattern with the increased rainfall over this belt, and we have a decreased rainfall extending from the northwest and the northern Pacific to all the way to the Indian region. This is the pattern we are getting, and the corresponding SST pattern will be is like this. We have a developing or something like a La Nina pattern with warming in the central Pacific, not central Pacific, close to date line, and we have a weak like IOD-like pattern in the Indian Ocean, and we have some warming in the North Atlantic region, and that extra tropics also. We have some warming pattern. This is the June-August rainfall and SST pattern. So if you come to July and September, what the difference is that this warming, this cooling is there still itself, and we have a somewhat more developed like IOD pattern, and this warming in the Atlantic is also more stronger when you come to the end of the season, like July to September, that period, and the rainfall distribution is like this. So still we have this as we show from India only zoomed Indian region, the same the decreased rainfall is persisting in the entire period for the later season also. It is persisting like that.
What is the lead month forecast?
This is not forecast, this is observation.
Ah, sorry.
The observation indicates the revival of the monsoon in July, and the total judges rainfall was above normal. SST pattern also indicated a weak liner-like pattern in the Eastern Pacific and negative IOD structure in the Indian Ocean. So this is what we observed as a season as a whole. So just as I want to see the monthly pattern, monthly evolution. So this is from the same from IRI website. So this is the rainfall, and this is SST and wind, and this is MSLP, and this is from GODAS. So I took from NOAA temperature profile. So when I plotted, this is the equatorial average plot for the temperature. So what we are getting is that June month, as we already discussed, there is a deficit rainfall is there. So what we have that, so we have this SST pattern is still that La Nina-like weak La Nina-like pattern was there in the Pacific, but that IOD thing was not that much developed, and there was no warming over the eastern. Instead of that, we are warming in this eastern region. So when we use different data sets, we have difference in the pattern that we will come to. I will discuss later. So we have a warming pattern here, and this and so the wind pattern is here. The diverging winds are there into the Indian. It's not coming to the Indian land region, and the dipole is also not stronger. So we don't have much wind pattern over here. So resultant that MSLP is also high over the land region. So the low MSLP, that means the convection is in the Atlantic part only, central equatorial Atlantic part. There's a more convergence is there, and so similarly, this is the rainfall. This is the same area which I am mentioning. So we have a rainfall over this region, and it's extending to this Indian Ocean region. So this is a pattern, and if you see the thermal profile of oceans also, we don't have that much La Nina developed profile is there for the month of June. Still, this is the pattern, and since come to July, this is next month, sorry, July month. So rainfall is again, as we told, is 17% for India, increase positive 70%. So we have a increased rainfall pattern again, and this warming is almost stronger, and we have a strong winds coming from this area to this Indian land region. We have a divergent wind when the equator deadline is reaching to Indian region, and there is also like some divergent pattern is starting from here. But if you see the MSLP data given by IRI, still India have a positive MSLP only, and that is I don't know why it is with this much convergence we have, but still MSLP didn't decrease in IRI data. Not sure. But that if you see the subsurface, that La Nina has a more stronger pattern in the subsurface, and you see the dipole also. If you see here, Indian Ocean has not that much no dipole-like pattern in the subsurface also, but it started developing strongly in the month of July, where we got this is the month where we got the maximum rainfall, and this is the observed structure of that month. So we have a like a La Nina pattern and something like a IOD developing, negative IOD developing pattern also there. Come to the month of August. This is August month. Sorry, this is August month. So this is again the rainfall pattern. So it's still increased rainfall pattern over here, and we have the same type of La Nina persisting, and we have this Atlantic pattern. North Atlantic we have a strong pattern, and a dipole is also there. If you see the pattern, such El Nino La Nina pattern is again stronger compared to the previous months in the month of August, and this now this MSLP is extending to the land region also. We have this whole area has a low pressure regions, like wind sea low pressure is low. And so this is the pattern. And if you come to June, September, the last month, so we have this increased rainfall over India, and La Nina pattern also. So still we can see this one pattern. So that's what I was telling, that when in that observation, this part of the wind is going like this. But in model, if you see La Nina time, this wind will all come to the land region in the CFS model. So we have to expect an increased rainfall over this region, because the La Nina diverging wind is reaching up to India.
Because wind divergence depends whether how it, if it is anticyclone. It is not going to increase.
No, but in the model we don't have this pattern is not getting. If you see the climate all pattern, all year together. So maybe. So this is what we are getting for the September month, and so all Indian land region and this extending from.
2010 also.
Sir?
Lynn has a 10.
Ah.
2000 also there is 2010.
Ah.
Not similar but milder compared to 20. La Nina was very strong.
But sir, model is more slave to La Nina. So it's a 0.8 correlation is there for the model. so when something is there, it should be more reaction should be there in the model.
Yeah, but there are easterlies, anomalous easterlies. Then it forms an anticyclone. Bay of Bengal.
Okay. So it should come to the Bay of Bengal.
Anticyclone.
Anticyclone. So the yeah. Okay. So this is the yeah. Yes, sir. We will see that pattern later. Yeah. Because I just want to try to link to this one. That's why. Okay. So this is the September pattern what we are getting. And then so there is a change of the decreased rainfall, undeveloped IOD and La Nina in June to increased rainfall, La Nina and a negative IOD by August and September. That is what we got from the monthly pattern evolution. So this is the I just compared June, July and September with the this data I plotted from NOVA I plotted this this is the velocity potential at 200 SPA. And this is the corresponding SST pattern. So if you see NOVA, this is a 5-meter temperature. This is more stronger than the whatever that IRA is giving the pattern. So what I observed is here is that this is a convergence center in the month of June. So and that is extending to the Indian Ocean, not over the land region. And there is a divergence because it's a upper level 200 SPA. So the lower level we have the opposite pattern. So and that is this is the like a warming SST we are seeing, and there is no IOD like pattern. But when you come to month of July, what happens is that this stronger pattern is here, North Atlantic, because we have a lot of peppers there, North Atlantic warming influence on the monsoon. So we have this pattern is developing here, and this because here we don't have not much equatorial cooling. Cooling is off the equator, I think. And here we have started that equatorial cooling is starting in the dateline, and we have a IOD also start developing. So due to that, we can have this instead of this convergence over here, the convergence center is like this, extending from Atlantic to Indian Ocean, and is covering over the Indian land region also. So this is the July time when we got the positive rainfall instead of the negative rainfall what we got here. So the pattern is changing like this, and this pattern continues to September also. Some changes are there, but still this warming continued, and this cooling continued, and that IOD also still like negative IOD is developing, and we have a good convergence over the Indian Ocean and the Atlantic region. We have the means Atlantic region, I mean Northern Atlantic region. We have a convergence and then a divergence over the extreme Western Indian Ocean south of the equator. Just one more slide, sir. Just one more slide. Yeah. So this is the pattern I got for the analysis. So I just so this is the wind pattern also. If you see, it's a June, the winds are from here, it's converging to this region, but in the month of July and September, it is coming towards the Indian land region. So this is what we got. So I just circulation pattern. I just compared with one of my paper. Just one more slide. So here we are in 2022. I published a paper with this is a SST pattern of North Atlantic SST. And it regressed with the total SST when after avoiding the effect of El Nino. So El Nino pattern is removed, and this is the SST pattern I got, and this is the wind pattern, and this is the circulation pattern. So if you see the circulation pattern, I have some resemblance here. So what I told the last time, and also wind also we can see here is a easterly wind to this region, and here is also a wind pattern converging to this region and a pattern. So that is what I am observing for this season as a whole also. Maybe, and there is no one to match between these two figures because here I have avoided all the total Illinois is avoided, El Nino pattern is avoided. So this is what I am getting. So with this I am concluding. CFS-V2 predicted above normal rainfall, weak La Nina and weak negative IOD for JJ season as a whole. And short-lived forecast shows the monthly pattern also. Major model forecast shows the same type of thing. Monthly evolution indicates that June month has a warm SST convergence over the equatorial Atlantic and associated with the decreased rainfall over India. La Nina evolution becomes stronger after June along with the stronger SST anomalies over North Atlantic and a convergence over the North Atlantic. And Indian monsoon region is with the increased rainfall. So this is what the observed pattern we got for the season as a whole. Okay, thank you.
You should know other models than CFS. Tell me, Prashant, one thing. Is what is that now our should be our objective to go to T574 in seasonal scale? Give your view, not your project director's view. Your view.
Yeah,
What should be our target? I mean, we should be happy with 10% getting a right result due to wrong reason, where we average negative Gangetic Bengal and positive rest of India, add it and get a good marks in the mark sheet. Or should we try to improve
yeah, definitely.
the four homogeneous region and bring
But-
the skill in the hind class
Yeah.
at least to 0.4, 0.5.
But still, sir, what you presented, what I presented, what he is.
Don't forget my presentation.
No. Every person, the area where you have the deficit or you have the problem is still there in every scale.
Agreed. And I'm asking
So
your
it is
opinion,
the-
how
so
do
my
you
point-
think to resolve this problem in seasonal scale?
Seasonal scale.
Yeah.
Yeah.
Because there should be a specific target.
No, but-
T574 with version 3 with monsoon.
No, but your question is that,
After so much of exercise,
yeah.
again, if you tell that I get plus 10% by taking average of Gangetic West Bengal and rest of India, will that be a justice? That's my question.
No, that's what I want to tell. Because
Yes or no?
no, simply increasing
No, will that be
resolution.
justice, yes or no?
No?
You said no.
No, you asked the question, whether you have to go to high resolution. So I will tell without increase why we should go to high resolution. Sir. Okay, sir.
July forecast based on June IC. Good.
Yeah.
So what led to that? That is a good problem.
Sir, June IC has
June IC based July rainfall over even the Gangetic plain was very good.
Very good, yeah.
Forecast was good.
Yes, sir.
Why?
Because June IC, we captured all the upside, whatever the deficit features of the June.
Again, July IC based August forecast is again bad.
Yeah.
Yeah, but another point is ECMWF got it right.
Yes.
You see the forecast of ECMWF.
ECMWF, the all the rainfall is from the western side of the India.
So that is,
Yeah, Raju. 100 range.
It is completely. Good afternoon, everyone. Am I audible?
Yeah.
Okay. So today I'll be presenting the extended range prediction of 2022 monsoon. And I must tell you that this presentation has been made with the contribution of all members of this group. So these are the outlines of this talk. First, I will briefly go through with this observed features of this monsoon season 2022, and then our new forecast strategies that is implemented from this season, and then overall scale of these new systems. And at the last, I will discuss about the forecast verification of different spells. So these plots you have already seen several times. So just if we look over this plot, that is the daily rainfall over all over the country as a whole, and the red one is the climatology. So basically, I want to tell you that during the June there was an extended break type situation over this month, and after that the good rainfall is observed over all over India. And at the end of the season, the departure was 6.49. That is a very good score actually. But if we look at the month-wise spatial plots of the rainfall, so June, you have already seen that except this region, most of the region over this part, except this and northeast region, got the deficient rainfall. In July, there was a good rainfall observed over this region, except these regions, northeast and this part of this region, Uttar Pradesh and West Bengal and adjoining part. And in case of August also, there was a rainfall band over these regions, and over this and this region, there was a deficit rain. And September, their heterogeneity is that rainfall distribution, the heterogeneity in rainfall distribution is more. That is, we can say the normal to abnormal rainfall activity observed over central part and core monsoon region. So this is the standardized rainfall anomaly over the core monsoon region. So we can see over this month, there was a huge deficit rainfall. And this is a Hogmuller plot during the JJS, averaged over 60 to 95 east, and with time and with latitude. So we can see this over the Indian land during June, there was a extended break type situations. And the 1st of July onwards, the rainfall revived. And this spell last for a long time, almost more than 3 weeks. And then again, there was a short, strong break during this time period. And again, there was a extended wet spell. And during this month, as we have already heard from the previous speaker, that 4 out of 6, 4 depressions were well-marked depression were formed during this time, a month of August, and 1 in the month of July, and in September 1. And so this is the active break spells we can say over the cold monsoon zone region during this season. And this is the observed MISO calculated from our own this MISO index. So we can see from this, the purple line shows for the June month, and the red one is July, and August is for this green, and September is the blue. So except June, after that, and you have to see this clockwise directions. So over the different phases during monsoons, we can see in the July onwards, this MISO activity was very strong, and it went through this active and break spells, and it continued actually till the month of September. But if we look at the MGO, so except the initial, and this is anti-clockwise directions obtained from the BOM. This is observed MGO. So we could say this from initial phase, there was a active convection over this West Hemisphere Africa, this region. After that, there was no significant signal of MGO during the entire season. So this is our new version of the ERP system based on a multi-physics framework. As we all know that the uncertainty in the model arises due to the uncertainty in the initial conditions as well as the model uncertainty. And the model uncertainty is basically the inherent uncertainty present in the parameterization scheme in subgrid scale. So with this view, we have developed a new ERP system, the version 2, considering, I don't know why this is coming like that, maybe due to the version problems. So these are the convection schemes we have considered. 3 convection scheme, that is simplified, Araqua Schubert, is SAS, and revised simplified, that is new SAS, and that is with new SAS with shallow convection scheme. That these 3 are the convection parameterization scheme, and these are to the microphysics, Jaugankar and Ferrier. So with these 2 microphysics and 3 convection schemes, we have taken 6 combinations, 6 type of combinations, and the base model is adopted from NCEP CFSB2. So with this 6 model, we have run this forecast during this season on experimental basis. And this is a seamless predictions. First 15 days we run with the T574 horizontal resolutions, and vertical resolution is 64 levels, which is same throughout the day 1 to day 36. And after 15 days, on day 16 onwards, the resolution changes to T382. This represents almost 23 kilometers horizontal resolutions, and this is 38 kilometers horizontal resolutions. So this is the multi-physics framework. So with this, we have already I have said the 6 combination of physics, that is NSAS with shallow convections and Jaukar and with Ferrier, and then NSAS with Jaukar and Ferrier, and SAS with Jaugankar and Ferrier, and all are having the 3 ensemble members. So altogether we have 18 members, and that is why we call multi-physics as well as multi-members. This is basically physics perturbations as well as initial condition perturbations. And we obtain this initial condition, atmospheric initial conditions from NCMR WF control as well as the perturb, and ocean ices from INCOIS. And with this initial condition, we run this different configurations with the CFS model. And at the end, we take these 18 members. And the mean of this arithmetic mean of these 18 members we call a multi-physics, multi-ensemble. And for the probabilistic, we consider these 18 members all. So to analyze the hint cat scale of these new ERP versions, we have also considered the existing ERP, which is operationally run in IMD. That is based on CFS, GFS with relatively coarser resolutions with 16 members as a whole. And initially we have developed this system with control only with 6 physics. That was shown in the previous presentation also, with CFS and 6 members with control only. So that time we had shown that as compared to the ERP V1, there's an indication of improvement in the forecast with these multi-physics versions. And that also is seen from this figure. Most of the subdivisions, these are this anomaly correlation coefficient during 2003 to 15. So most of the subdivisions, we can see the higher correlation values in week 1 lead, week 2 lead, and week 3 as well. So at that time also we conclude that there is a possibility to get the improved skill with the inclusion of more ensemble members. So from this year onwards, we have included 2 extra members, part-time members for each physics. So already I have discussed, so 18 members. So with these inclusions, we have seen this improved skill over the first week 1, week 2, and week 3 skills. But since in the longer skill, the probabilistic forecast has a better significance than the deterministic one. So we have tried to see the probabilistic skill as well during the hindcast periods. So this is the Breyer skill score calculated over the hindcast period and for different categorical forecast, that is above normal, near normal, and below normal, which is calculated based on the tercile method. So this is ERP V1 for week 2, week 3, and week 4 to see the how this is giving the improved forecast in the longer leads. And this is ERP V2. So we can see, especially in week 3 and week 4, the forecast skill is improving. Basically, BSS gives the relative forecast skill compared to the climatology, forecast skill compared to the climatology. So we can see it has a very good skill in the longer lead as compared to the climatology. Towards 1 means it's a very good skill, and towards 0 means it's a reduced skill. So this is for above normal category. And this is also the same skills for this below normal category. So we can also see from this, most of the subdivisions shows this, show the improved skill with the week 3 in the longer leads with these new versions. So this is the again anomaly correlation with the percentage departure of rainfall anomaly over the different homogeneous region that is given here. So this is particularly for 2022 monsoon. So this is week 1 lead, week 2 lead, week 3 lead, and week 4 lead. Sorry, I have forgot to mention what is week 1 lead for this new audience. So week 1 means we have we run this model in each Wednesday. So after 1 week, we run this model. So we have a different each IC on each Wednesday. So taking the first 7 days from each IC, we prepare this week 1 lead forecast, and taking the 8th to 14th day, we consider this and week 2 like that. So in week 1 lead, we can see up to week 3 leads, there is a significant skill, reasonable skill over this different homogeneous regions, central India, core monsoon zone, northeast, and all. But if we see in the longer lead, this is a deterministic skill. But if we see in the longer lead, the monsoon zone and over the central India, we got a relatively very reduced skill. But interestingly, over this northeast region and this year, we got a very good skill. So this is another example of the seasonal cycle, how it captured this seasonal cycle of this monsoon over this monsoon core region. So the gray bars are the observations, and this black, blue, and these green and red are the week 1, week 2, week 3, week 4 leads from the multi-physics ensemble forecast. So we could see that in week 2 up to week 2 leads, it could capture the rainfall fluctuations very well. But in week 3, week 4, it captured the fluctuations, but the magnitude it could not predict. This is another example of this verification plot of area average percentage departure of rainfall anomalies over this monsoon core region. This is valid for week 1, week 2, week 3, week 4 leads. And the purple line shows the observations percentage anomaly. And for this different week of this season, starting from 1st June to September end. And these are the probability. Blue represents the above normal probability, and green is the near normal, and red is the below normal. So we can see in week up to week 2, it could capture this rainfall variations very well. Week 3 also, it could capture the rainfall variations very well, except at the beginning stage of the monsoon and at the end of this monsoon season. And week 4, it shows the similar kind of pattern. So that could be the reason that week 4 lead we got a very less skill, because this is totally out of phase with a huge difference in magnitude. Here also it is out of phase, but it's less actually. But in week 4 leads, that amplitude is in opposite phase with a huge difference in magnitude. This is another example of Northeast India. Over Northeast India, you can see the observations. It almost towards the negative side. That is the observations. And model also shows the reduced probability very well in all over this during the all leads. So that is why we got this. So basically, model could capture this subdued activity, rainfall activity very well in almost all leads this year. So now we will see these different phases, transition of phases, active to break to active, like that, and for which this ERP system is well known to all. So we'll see this fluctuation, this transition, how this model could capture these fluctuations and how many days before. So this is the whole, I have mentioned that this whole June was in break phase, then 1st July maybe. These are the approximate dates. So the 1st July was, it went to the active phase, and again, at the end of July, it went to break phase. That was a strong break phase, then again active, like that. So I have considered this only transition phase, the week-wise verifications. Okay, so before going to the verifications, we have checked this during the onset phase. We generally see the westerly depth, how strong it is to maintain the monsoonal activity over this Western Ghat, and then again towards the interior part of the Indian region. So we can see the IMD has declared the onset on 29th May. These lines represent the same. And this is the observation. This is from the initial condition 18th May and 11th May. So we could see this in observation after 29th May. The westerly depth, the strength of the westerly depth is reducing, which was very well captured by these two ICs from the model. So these are this is the week-wise verification for this target week 3 to 9 June. So this is the observations, and this is for multi-physics from nearest 3 ICs, and this is the ERP beyond. I have kept to show just relative performances. So we can see this in the beginning of June, there was no sign of good rainfall activity except these few parts of the southern region, and that was very well captured up to week 3 leads in the multi-physics. But in the existing versions, it could not capture in the week 3 leads. This is another example when the monsoon went from this break phase to active phase, the beginning of July. So you can see the rainfall distribution. This is observations, and this for the same for nearest 3 initial conditions. And we can see over these regions particularly, there was a huge deficit rainfall, and that was very well captured with the model up to week 2 leads. But in this is the this is with ERP V1. This is written here. So although it could capture the deficit this rainfall activity, but the magnitude was very less. But as compared to that one, V2 is the amplitude was predicted very nicely. So this is another example of active to break phase during the 29th of July. The week started from 29th. So we could see this particularly of this Western Ghat and Central India, it is a break-like situations, and rainfall band is moving to other foothills in that region. So that was very well captured, the propagation. From MISO also we can see the phase propagations. The green was represent the MME with spread, and the blue lines is observation. So we can see it is moving from central India to the Indian Ocean and convection. So it's clearly saying this indication of a break phase from 13th July initial condition. What is going to happen in the end of July? So from 13 initial conditions, we could see the indication. So this is from break to active phase conditions. So we can see from observation there was an active like situation over this region. And also during this time, there was a low pressure system developed over these regions and moved towards this. So that was well captured by this MME in week 1 lead. In week 2, there is a indication, but not that much prominent. But it completely misses in the TRB week 1.
How do you make this anomaly?
Which one? This one?
The anomalies are made.
This is anomaly is for this week only. It's a weekly average.
Correct.
And taking this
You
real
have-
time.
You have 18 cases, right? You have 6 physics cases.
Yes.
And 3 types. So 3 into 6, 18.
These are mean of all.
And then what do you remove?
This is model climatology. We run the hindcasting on the fly also. Yes. So we run this model on 20.
Take physics to physics the same when you take the difference.
All models are run with the same axis.
Okay, yeah, the multi, yeah, but when we do the machine, first you take this physics from the hindcast, physics, then subtract, then
We have 6 models run with the same starting day. So we average in the lead with the day lead, and they take the arithmetic mean of this all 18 forecasts.
each physics behaves in a different way.
Yes.
So when you take the difference in the hindcast, you should take with respect that particular physics.
Sir, that is also taken care of, no, sir? We are taking mean of 18 for hindcast as well as for the rest.
You are mixing the different physics.
Mean of all these physics and their example for the mean of all together for deterministic purpose. But when we are going for probability.
No, but what you are telling is correct. That's the way.
Should be, but.
Otherwise, you are smoothing out.
Model by model, it will cancel.
That's not the purpose. If I have A, B, C, D, E, F, G, okay, and I have hindcast of each one of them, I should treat an anomaly with respect to each one of them.
Yes.
I cannot. That's a simple logic.
You will get the same thing, but.
No, whether we get same thing or wrong thing, that's a different issue, Saji. The point is, we even in our hindcast, we have 21 member, right? We don't mix up. It has to be anomaly with respect to climatology of A, of B, of C,
No,
and then you can.
No, it cannot be. In 21 member, what will be?
No, I'm saying it is physics.
No, what?
In our case, it is different.
So don't say your case.
It is a part of initial condition is
When
different.
we are showing.
But if you do physics, then I think that.
When we are showing, we are showing kilometer. When we are showing probability, then each member is dealt separately.
Correct. But when you do anomaly,
Yeah.
that's the question.
Sir, let me ask you. We have 6 physics with 3 ensemble for each.
Correct.
So you are telling to take the 3 means for individual physics and take the different anomaly for
you are
individual.
taking mean of all these 6,
Yeah,
right?
I'm just.
Then you are taking when you are calculating the anomaly.
Yes. Sir, individually doing 3, 3, 3, then again we will be March 6.
Yeah, okay.
So instead of that, we are doing 18 at a time.
Yeah,
There won't be too much difference.
Yeah, fine.
Correct. I think his approach is different. Probably.
Whatever approach, just.
So that is why we are for probabilistic as well.
Probabilistic only it will be defined. Probabilistic it will be defined, but mean.
So that is also we have tried to see the probabilistic.
Exactly same. Right, the
Mean is
exactly same.
Listen, Sahaji, I am not telling different what you are telling.
Yeah.
Okay, why you are saying? I am telling
Mean, if you tell mean, this is the same. What you
Mean
are
is
saying same, but probabilistic, it may be different.
So probability we are saying.
So that is why I told you.
Yeah.
Taking a mean of 18 ensembles to at a time and taking three
Right.
means separately. Okay, so I landed in the last slide. So summaries, we have seen that in case of deterministic scale, the ERP V2 outperforms ERP V1 up to V3 leads over most of the subdivisions regions, not everywhere. And in terms of probability skills, we have seen the below normal, above normal category shows better skill with ERP V1 in the longer leads, that is V3 and V4. And also we have seen the MPME could realistically provide the outlook of the interseasonal fluctuations within during this current monsoon season. And also whatever I have shown the initial results only, and we are doing the detailed analysis of this 2022 monsoons, and that is being carried out. So maybe in near future we could show. Thank you.
Thank you.
No question. Any questions? Otherwise, okay.
We'll have it again.
Okay, thank you.
Yeah, you have your tea, Ramesh.
लेके जाओ यार ठीक है
So, Namaskar. So I will be talking about East India deficient over the East India summer monsoon rainfall. Means that is the reason that during this season there was a deficient rainfall. All over India means monsoon behaved very well, but during this year some. Okay, so we have seen all these things. So what I want to mention that East and Northeast India. During June, it was in the positive side and rest of the India was in negative side. So, and after that, in July, it was the huge deficient over this region and it continued. Okay. So, and this is the cumulative. So all over season as a whole, Northeast, East and Northeast India was in negative side and rest of the India was in positive side. So then what happened during this period that during June, there was very good rainfall, and during this period, from 1st July to 18 July, it was a very deficient over this East and Northeast India. And as a cumulative, we can see that the main disaster happened during this period, and this curve has gone down. And rest of the India, you can see that curves are going up, and it persists throughout the season. So I have taken this period, and then I have tried to connect that for the whole season. So this already we have seen that during June, this Northeast India got very heavy rainfall, and this East India means Bihar and Eastern UP. So I am mainly concerned for that one. So, and then in July it was even more in the deficient side. August, again, it was in deficient side, but in September, it is in mixed. Okay, means the rainfall, some rainfall occurred over this region. Already it has been shown. And this we have already seen so many times. Okay, so here actually in this period, this monsoon is very active. It is showing very active rainfall, but over that reason, Bihar and East UP, it was very deficient. Overall, monsoon performed very well. This also we have seen, again, only the special pattern. And this is for the temperature. So temperature was, again, it was very high temperature. This, this region was already railing over this overheat condition. Already Ms. Parthasarthi has already had talked about the stress conditions. So this is as a season as a whole, I think. Yes, this season as a whole, it was it was very hot, and this also already it has been shown by him. So means here Bihar and East UP, you can see over this period there was a very deficient. These 3 weeks were very deficient, and all means some rainfall occurred during in the month of September. And as a community, we can see this over this region from Gangetic, West Bengal, Odisha, Jharkhand, Bihar, Eastern UP, and Western UP. Means the huge deficient occur over this period, and it continued. Means it was never recovered. Now the local features. So during that period, from 1st July to 18th July, means what has happened. So this is the climatology. You can see that this region gets means good rainfall during the month of July, but for 1 to 18 July, you can see that all over India means rainfall was okay. It was a heavy rainfall, except this region. Over this region means there was no rainfall. And this is 500 HPA omega. So again, you can see here there is a subsidence motion. Here means monsoon was active, so it was upward motion, and over the Tibetan plateau there was subsidence. And for this surface pressure, again you can see here means there is a high means masculine high was much intense, and over this Tibetan plateau also there was a high pressure, and in between there was a low pressure area. And
Which
over
analysis
this,
you are doing? Which reanalysis or analysis?
reanalysis, NCEP.
Answer.
So likewise means this is the temperature, 2 meter temperature. So where there was high pressure cells means temperature is low. Here over Tibetan plateau also it is low, and here means because rainfall occurred, so it has cooled the surface temperature. So it persists with the surface pressure. So means it was a tripod type of structure. It's high, low, and high. So what it did that because that pressure gradient was too high between these two regions, means masculine high, it was very high pressure. So it has pulled this monsoon flow. So monsoon flow was very intense. This is the climatology, just for comparison, you can see. So, and this monsoon trough, you can see from this climatology, it was south of its normal position. So this because why it was south of the normal position, one thing that surface temperature was much higher over this North Arabian Sea and over Bay of Bengal, and also surface pressure was very low over here. So this has pulled this monsoon flow towards this was south, and also this maybe one of the possible reasons that because of this high pressure over here, so this pressure gradient didn't allow this monsoon trough to penetrate more towards this North India. And this is 200 HPA geopotential. So these contours are climatology, and these shadings are anomaly everywhere. Okay, so so here you can see that upper that Tibetan high has been shifted somewhat northward, and also this core of this Tibetan high is in the west, northwest direction. So basically, this itself can pull the monsoon southward, westward, and maybe because of monsoon, this has this Tibetan has been shifted northwestward, and because of that, what has happened that this Sterlis, you can see, means that Tibetan high has been elongated. This is the normal. So this is the normal condition, and here this is the from 1 to 18 July. And over this region, what you can see that because this has shifted northward, so over this region, easterlies are very strong. So this easterlies, because this is the region where means if tropospheric winds here is minimum, that will support this convection. but because this has shifted northward, so here means these easterlies are very strong. That has intensified this tropospheric winds here. So here is a paper. So this slide has been provided by Mona Lisa, SRF, IITM. Huh?
1 minute. Slide मोने वाला है.
करो. In our paper means what, and in our paper, what we have shown that so this is the climatological picture you can see over this North India. And this winds here is very means it is very minimum, and this is for 2022 from 1 to 18 July. So winds here has increased, and this is the correlation. So over this North India, when winds here is minimum, then that is good for this convection to occur. So now means these are the local features. So now we have tried to look at what are the global influence that are influencing, that are making this Tibetan high means to move to shift northward and become much stronger. So first is the Atlantic influence. Already means it has been shown by him that Atlantic was much warmer. So this is the picture means already many times it has been shown. So here you can see Atlantic is much warmer, and this warm Atlantic, what it will do, it will intensify the ITCG over there, that place, and because of that, means already means just to show this is the climatology, and this is from 1 to 18 July. So this ITCG was much intense over this region. And because of that, what will happen, just like PNA type pattern, it will form a wave type wave over this region. So you can see this negative, positive, negative, positive, negative, positive. So it is coming up to here. So this will intensify this Tibetan high, and it will make it elongated along that region. So this is one of the region. Now next means the same thing. Already means after that, this is small waves you can see, and in the southern hemisphere also there is wave because of this one. And this is again just the this is the climatology, and this is from 1 to 18 July. Again, you can see the Tibetan high, that core has been shifted northwestward and northward from this normal position, and it was much intense. And again, means this has been elongated. So now the second region is Azure high. Means, so here you can see these contours are climatology, and this shading are anomaly during that period. So here you can see that Azure high was much intense. And here means this is the actual means from 1 to 18. You can see that it was much stronger and much elongated towards north. So what it has done, it has intensified the jet stream over this at its beginning, and also over this northern Mediterranean, Black Sea, and over this India region. So this jet stream itself acts as a wave guide, and we know that when jet stream is much stronger, it shifts the means monsoon is much stronger in the west. And because of that, at the upper troposphere, this dipole type structures is developed, and this is the means we have shown means already we know that because of that, this wave type pattern it generates means that Azure high generates this wave type pattern, this positive, negative, positive, and this is going to intensify and shift this Tibetan high towards northwestward direction. So this is another region. So already means we have already shown this thing that when Azure high is much intense, so it forms dipole type structure at the upper troposphere, and this will intensify this jet stream. Over this low will intensify this jet stream at its interest level, and it will intensify up to this, and this again shifts the Tibetan high westward, northwestward. And this is the 200 HPA divergence and 200 HPA geopotential height. So here you can see these are the region of convergence. Means this is the region of Azure high, means it is the region of a strong subsidence, and upper troposphere there will be convergence. So here also there is convergence, here also there is convergence. And wherever there is upper troposphere convergence is the region of Rossby wave source. Okay, so this is because of this formula. So here you can see there is a divergence, but it is negative. So means upper troposphere convergence. And during this is 200 HPA omega. So here what you can see that ITCG was much intense over this region because of this African ITCG was much stronger. Because of that, there is a strong subsidence over this Mediterranean region and over this Azure high also. So this has intensified this Rossby wave source over this region, and also this comes in the path of this Silk Road pattern. Okay, so this wave was also very active. Again, the same thing, and this is the symmetric diagram. This when this upper tropospheric high is over here, so it means this cross equatorial flow is much intense, and it runs mostly over this western India. Okay. So now the monthly comparison. So this is for June, July, August, September mean sea level pressure. So here these contours are climatology again for the month of June, July, August, September, and these are the anomalies. So again, here you can see that in the month of June, Azure high was much stronger. Then again in July, September, August it has shifted northward, but it still means that influence will be there. And in the month of September, it has weakened. And already means you can see here there are so many contours, but here only one means Azure high itself means decreasing during the month of September. So means that influence was not there in the month of September, and this is for the again means sea level pressure for that Indian region. Here again you can see this tripod type of structure, this positive pressure anomaly over here. Then again it has intensified. Then here it has gone. Okay. And this is 500 HPA omega. Again, this subsidence was here, and this is Azure high. Here again means the same thing. And here means that subsidence has decreased and also has gone to opposite direction. Again, 2 meter surface temperature, this negative, and this has decreased in the month of September. Now, one more comparison that from 1 to 4 September, just opposite thing happened. At that time, only this eastern UP and Bihar was raining, and rest of the India it was dry. So I tried to compare both of them. So here you can see this is rainfall. So it was raining over this region, and rest of the India it was dry. And this is for 1 to 18 July, when means this period was dry, this region was dry, and rest of the India it was raining. So what happened during these two periods? So this is the 850 HPA wind vectors. So this is for 1 to 4 September. So here you can see that monsoon is weak. Okay, that flow is going even south of the peninsular India, but this flow from the North Arabian Sea, it is converging over this North India. And this I have shown. This is for 1 to 18 July. So here this monsoon trough was intense, but itself means again here it has bent towards south, and this monsoon trough was in the southern, the south of its normal position. And this is for the geopotential height. So from 1 to 4 September, you can see the geopotential height, its position and its core. And during this 1 to 18 July, you can see that this geopotential height, it has been intensified, shifted northward, and its core is in the northwest to its normal position. And this is this upper tropospheric wind vectors. So this is for 1 to 4 September. So here you can see this wind shear, it is minimum. And here for 1 to 18 July, it is maximum. because this already I discussed, so that has shifted now. And here, this is again, you can see for 1 to 4 September, this winds here is minimum over this North India. And bus finish. Okay. So this is a difference in surface pressure, just opposite. Okay. And okay, thank you. So,
Okay.
What is the time period of wave?
huh?
Time period of wave?
Time period of wave.
Or wave number?
No, wave number, it is a planetary wave, no? Wave number 7.
Yes, specifically during monsoon season.
It's that monsoon season I'm talking. And when that wave is not active, then there will be short waves. So short waves, that number will increase.
So Ramesh, my question is, so this is understood. Why that northeast rain 50% high in June, and why the magnetic plain did not rain in June, July, August? It's understood, right?
No. This is the open question for you, no. So if you agree my hypothesis, it's okay.
Because I assume that I agree.
So see rest of the discussion they have gone to El Nino and IOD. So here this El Nino IOD is not able to predict.
Give a pause. Let us take a null hypothesis. Okay, you are right. Okay. You're right. I agree with you. My question is, so you are actually playing with a large scale planetary, wave number 1 or 2. My question is then, the model, do you feel they don't capture all these large scale features?
Model means I didn't got that.
I mean, all this climate model, whatever you see from 230.
Not prediction group, but they
No. I mean, you have seen here slides, right? From Srijit, from Prasan. Climate.
So many slides.
So Azure side, no. My point is, you have basically Azure side, the Tibetan anticyclone and so on, and the large scale planetary waves and all these things.
Yes, sir.
These are supposed to be resolved by climate model, yes or no?
I don't think so.
You don't know. Then my null hypothesis fails.
It should be interesting to see in model also this kind of.
Yeah. Model he doesn't know. He stops with the null hypothesis. So you have to take it forward and prove.
No, he tried to get that.
Another aspect.
They are not storing the.
No, even in free run, you can see the teleconnections if it is there. We are not seeing. But this kind of teleconnection, whether it is there or not, that will be interesting.
Yeah.
What is this? So,
Yeah. 23 minutes late.
10 मिनट में खत्म कर Actually, the thing is that the observation thing starts. We have started to the analysis right now, and all my previous speakers have told why this thing happened, what those things happened. So what I have to tell, I have nothing to tell outside. I can only tell from my observation that what we have told is exactly right. That I want to prove.
You're right.
Okay, so somebody told there is a deficient of the June rainfall. Somebody told there is a excess of the September rainfall. So I wanted to tell yes, right. The ground truth I'm showing to you while you are right. So hi, this is Dr. Kaustav Shagavate. I'm from the observation group, and we have got the observation I've taken. We have got an instrument known as hydrometer that measures the raindrop size distributions and also the rainfall intensity and various other parameters. But as I told you that we have started our observation now, we have hydrometer at several places of India. But right now I will be only focusing in some of these places, that is Mumbai, Pune and Mahabaleshwar, and the Madhya Pradesh, that is in Bhopal and in Calcutta. So it is covering more the cold monsoon zone and the eastern part and the western part. And the two regions are there. There is a Mahabaleshwar, that is of course the extreme heavy rainfall region, and we are very much fortunate to have our cloud physics laboratory there. And also the two places in Madhya Pradesh you can see, one is in Bhopal and the other place is in Silchara, where our atmospheric research test bed the first time over India is happening there. So I will be more giving stress on these three regions. So I'm going to the IMD rainfall thing. So this is the daily rainfall climatology of Santa Cruz in Mumbai, where we have kept our instruments, and you can see this is from basically from the IMD. This is the daily mean for 1998 to 2021, and what has happened over 2022. You can able to see from here. That is up to 30th September. We have got the data. And of course, you can see there are some spikes of the heavy rainfall around 200 millimeter per day around in the month of July, and some in the month of August, and mostly in the month of September. Well, next go to the Ashan thing, and you can also see in the Pune, we are also seeing around a bit latter part of July, in the mid-July, and also in the month of September, and there are some very severe rainfall happened in the very severe rainfall happened in the month of October, where you can see that around 95 millimeter rainfall, 52 millimeter rainfall happened in Pashan. So these are the climatology, and with respect to the present rainfall in for the year 22. This is Mahabaleshwar, yes. As Dr. Muhova that told, so the Mahabaleshwar extremely heavy rainfall does not able to capture by any models. Yes, in some days 22 rainfall, it has 300 millimeter per day. It has happened. And most important things, this time Mahabaleshwar has comparatively less rainfall than the other years. Last year it was around 600 millimeter per day, but the highest rainfall this time went with the Mahabaleshwar is around 300 millimeter per day. Yeah. So this is the climatology of the Bhopal, where you can see that it's not, it's more or less not so much contrasting features which we are seeing. And this is over Calcutta, the eastern part. Yes, I have got the data up to the September 30th, and you can see that we can see some spikes over this region, that is 70 millimeter in the month of June, and some in the month of August, and one in the month of September. This is the general features with respect to the climatology and what has happened for the year 2022. Now, as I'm telling to all the modelers, what the thing has happened. See, for the month of June, if you can able to see from here, that the climatology, take the case of Mumbai, the June month 22 has 291 millimeter compared to the climatology is 585. Look for the month of Mahabaleshwar, 950 is for the June, but we have got only 346. Now go to Pune, come to Pune. It's 183 climatology. We have got 13.7 in 2022. Bhopal, the Central India test, Central India region, 152, 66. And when you are telling for Calcutta, 240, it's 164. So all of your assumption is absolutely right. That in June we have got extremely low rainfall. While take the case of July. July we are seeing it is shooting up. Take the case of Mahabaleshwar, Mumbai 1244 with respect to 964. Mahabaleshwar it's a bit more, and Pune also it's a bit more, and everywhere it is a bit, except in Calcutta it is 192. We are getting less rainfall in July. Now take the case of September. September you can see that in Mumbai it is much more. With respect to Mahabaleshwar it is less. So this year Mahabaleshwar has got a less rainfall with respect to the other years. And you can see this is the statistics. Pune, yes. Important thing is see for the month of September and October. October, there is a huge things that what has happened in the October. See, every place October has got a severe rainfall. For example, take Mumbai. 91 is the climatology. We can see 226. Take the case Mahabaleshwar. Yes, it is slightly more than the climatology. Pune, it is excessively more. That is 62 is the climatology, and we have seen it's a 228 millimeter in Pune. Now, also it is happened in Bhopal and Calcutta. I have not got the data till now. In Bhopal, it is generally 32, and it's 2022 it is 122. So it's all over India. We can say from the western part, central, and the eastern part, the October rainfall is naturally more with respect to the other years. We can able to see.
So the second column is from rain gauge, right?
All this from rain gauge.
All from rain gauge.
Yes, all from rain gauge.
Very, very nice. Long and Guwahati also.
Okay. So I have not put, but next time.
This is district average.
Huh?
District average rainfall.
This is station average. Yeah.
Because you will have the distribution over the central.
No, I have not put the
Northeast, Calcutta is in the eastern side.
Calcutta in the eastern side.
Something you.
I have not put because we do not have the disdrometers there. So I will compare this result with Shillong. Any site we have a disdrometer because the ISRO has a disdrometer. Yeah. Actually, I have not got 31st. I have got up to 20th October. I have taken it's up to 20th.
Rain gauges, right?
Rain gauges.
Yeah. These are for rain gauges.
Rain gauges. Now I come into to the disdrometer. Yeah. So these are the 5 places I have chosen for the disdrometer. So as Mukhopadhyay sir was telling that what is happening with the rain intensity. This is from the disdrometer, the intensity of the rainfall, which we have got. So it's millimeter per hour. So rain disdrometer measures the rain rate and the rain drop size distribution for every 30 seconds. So we have taken, you can see Mahabaleshwar, Bhopal, Pune, Silchar and Calcutta. You can see this is for the month of July. You can see this is rain intensity, that is millimeter per hour for the month of June. You can see the percentage occurrence for Calcutta is more. Then comes Bhopal, then comes Silchar. Silchar is our central India test bed site. Then comes the Mahabaleshwar and finally comes the Pune. So this is basically the number amount of rainfall in millimeter per hour. Intensity is much more in Calcutta with respect to the Pune. One important features which we okay, I will say in the last. So this is you can see the percentage occurrence of the rainfall which we have got and the number of events we have got. This R1 is 1 millimeter per hour and above number of events, and R11 is basically 100 millimeter per hour and above. I have compared all the places. Percentage occurrence. You can see from here that take the case of Mahabaleshwar. It's 14%. Bhopal is 28%. So what are the total samples we have got in this variation of the classes? And we have seen from here that in the month of June, none of the station has received 100 millimeter per hour and above. Generally, it receives due to the thunderstorm rainfall, but in the initial part of the June. But this year, we have not received in the month of June 100 millimeter per hour and above, some samples. But see, go with the month of July. You can see in the month of July that again, the Bhopal and the central India, it is coming comparatively, it is got the more heavy rainfall intensity this year. Compared to the western side Pune or the compared to the western side Mahabaleshwar. You can see from here that this Silchar Bhopal and it is most probably Calcutta. Yeah, these 3 stations, because from the eastern side to the western side, the intensity of the rainfall has increased with respect to the western side. Central India this time has got the extreme severe rainfall event more with respect to the western India. That is the thing you can see from here that 60 millimeter per hour and above has got more in the Calcutta, Bhopal and Silchar with respect to the Pune or the Mahabaleshwar, which is not generally the case happens in the every year. So see, take the case. Silchar, there is central India. Mahabaleshwar has got a rainfall in 7 events, 7 cases. Mahabaleshwar has got rainfall more than 100 millimeter per hour. But see what happens in Bhopal. Bhopal, it is 7 events. It happened 7 instances, and in Silchar, that is also in the central India where our site is there. It has got 32 such instances where the rainfall exceeded 100 millimeter per hour. In Calcutta, it is 1. So the percentage of rainfall you can able to see it is arranged in this manner. But one of the why Mahabaleshwar has got a severe rainfall, yes, you can see from here that Mahabaleshwar has that's rain R1 more than 1 millimeter per hour. All the things are much more higher. It is 31,505 instances, whereas in Bhopal and Silchar and Pune, they are comparatively less. So the total rainfall of Mahabaleshwar is much more higher. That is 6,000 or 6,500. But the intensity of the rainfall, which is happening over Mahabaleshwar, Bhopal and Silchar, the central India, that is Silchar or the Bhopal, is much more higher intensity with respect to the Mahabaleshwar, at least for this year in the monsoon months. Now take the case of August. Yes, The August also you can see the Calcutta has gone behind. The Bhopal and the Silchar, central India has got a very high intensity of rainfall, and that has also been observed over here. You can see we have got some 100 millimeter per hour and above 3 instances, 1 instance over Bhopal and Silchar. While Calcutta, we have also got some several instances at 19 instances over that region. So now take the case of September. September, you can see the central India is coming down. Calcutta is going higher with respect to the severe rainfall. And you see important thing, Pune is growing up. As you can see from the month of September, the rainfall intensity, the severe rainfall over Pune has started to grow up from the month of September. And we can able to see the features. We can able to see from here. See 5 instances. The central India is not have. We have, but the Mahabaleshwar has 6 instances. So the high intensity of rainfall over Pune is coming up during the month of September. Now, there is a go with the month of October. That we have taken up to this 20th October. We have also seen here that Bhopal has high intensity. Also, Pune has the number of higher intensity of rainfall over Pune has got increased. And that also with respect to the Mahabaleshwar. So there are some doubts that there was Pune received some 1 or 2 instances higher rainfall more than 100 millimeter per hour. But you can see from here that the higher rainfall instances of over Pune has got increased with respect to the other regions. So the percentage occurrence of the higher rainfall has increased in the month of October. So this is one of the important features of this thing, that the October rainfall, see for here, that the Pune has got a very severe rainfall during the month of October with respect to the other parts of the Indian region.
Okay, so just one clarification I want. That instances which you are telling for this 100 millimeter per hour category. Suppose in the same rain event, if it's rain twice that 100, so you will count as 2 instances or 1?
We call it every 30 seconds. It is a sampling interval. Okay. In 130 seconds, it has gone up to 100. This is 130 seconds. Might be it has started from 50, 55, 60, 65. Okay, so one instance it has gone to 100 millimeter per hour.
Okay.
So if that type of rainfall happens in that 30 seconds, it will be 100 millimeter in a single hour.
Okay.
That is a sampling interval.
Percentage, how do you have up to 100% means what? How you calculate a percentage?
Which one?
Go back to percentage figure.
So that is the total amount of rainfall greater than 1 millimeter per hour. So we take it as 100. It's a percentile basically. Total amount of rainfall greater than 1 millimeter per hour. So that is a percentage. With that respect, we have counted.
Percentile.
Yeah.
Is that 100 millimeter per hour means throughout the hour it is continuing?
No, 30 seconds.
30 seconds only.
30 seconds.
Otherwise everything would be cloudburst.
No. That's why I've clarified it. In one instance, if it rains in that way, it will be 100 millimeter per hour. So this is all the detailed features of these several places drop size distribution is going on. We have also got a very contrasting features. I could not able to show in a very short span of time. Means I'm just analyzing. Might be in 1 month we will able to do all these drop size distribution variation, and we can able to show that we also have a disdrometers at Cochin. We also have a disdrometer at Delhi. वहां से आने के लिए दिवाली का थोड़ा टाइम लगता है. क्रैकर में एटीन्यूएट हो गया, टाटा आ रहा है आते आते. So by month of November, we can able to complete all the analysis and show you the details variation of the rainfall distribution and the rainfall drop size distribution for all these places over the pan India. With this, I end, and thanks to Dr. Hosalekar who has provided this data, and we have 2 project scientists who have really helped with that, and all the staffs of HACPL, Mahabaleshwar and ART, and this one, it's training. Thank you.
Need to Sameer's question. So if next 30 seconds here it is 100 hour experience.
2 events, 2 instances. 1 minute and 30 seconds. It's like that.
Not continuously for 1 hour.
No. I am telling that if this rainfall continuously hoga, that is a severe thing. It will be coming in this. Yeah. But
I thought this is very simple. It's not that simple.
Not that simple. So all the analyses are going on for the detailed variation of raindrops. And
I thought a Calcutta में कुछ rain हुआ ही नहीं है. You इतना 100 millimeter per hour. I got
Yes,
confused.
yes, we do not follow that.
No, but Pushpa, tell me, what is the take-home message from this slide?
I will take home message. First message is that this year the central India has got the extremely severe rainfall events. Central India, that is Bhopal and the
Other year nahi milta hai.
climatology it is showing like that, and also the rainfall intensity. I'm telling that. I'm telling about not the total rainfall, rainfall intensity.
But particular year has not been analyzed. It is climatology.
No, sir. You can see here has been analyzed now. You can see from here, sir.
So, no.
This is year has also been analyzed, and also the intensity of the rainfall.
No. You showed all these things, no? That spike. Show that figure.
This one? This one you want to
show to captain of weather officer. Yeah. So here, what is happening? Okay. I'm a layman. You are actually comparing a T20 match with the total career average of, say, Sunil Gavaskar.
No, exactly not. I'm doing.
But his spike is Virat Kohli. Climatology is the total innings of a batsman. You know.
No, why you taking a comparison? You take it differently, sir.
This 12 August.
Yeah.
This 12 August, this climatology means it is 30 years. Okay. It's not, but what this blue?
It is a 22.
That's what I'm doing. This is T20.
Yeah.
This is average. Day of boycott. Understand?
Yeah.
In that.
Yeah.
There can be some spike. We don't know.
Maximum we should
all year by year.
That's what I told. Good. Understood.
Yes.
Difference between.
Thank you. Something
different.
Good initiative. Also, it looks like the season has shifted from June to September to.
Cost of it is good initiative from observation.
I have tried to do, and all the other stations are there. We will do all those things. Every 30 seconds.
This thing you included October.
Yes.
So Pune. No, Pune spike.
Pune spike.
That's why we're not getting any spinach in the market. If Prasan is a representative, if flooded all the hive things.
University shows that the flooding is caused.
Okay. Huh?
One speaker is online.
Okay, good.
Okay.
Thank you, sir. Thank you.
Good. Thank you, sir. Thank you.
Yeah. Krishna, you can share your slide.
Yes. Sir, can you give me permission to share my slides?
We cannot see. We can hear you.
Padmakar, he needs permission. He's not able to show.
Okay. One minute.
Previous person and share it. Automatically, he should be able to share it. The previous person share that.
It is, but sometimes it.
Hello. Yeah, please. एक्चुअली मुझे वो ऑप्शन नहीं मिल रहा है परमिशन है
Share tray. Open share tray.
Open share. Click there. You have to click there. Click on the arrow. Click on the arrow.
Yes,
This is Subodh is doing.
Just move the mouse, then you will get something.
Yeah, I cannot get any option to share my screen.
Can you send your file here?
Yeah.
So he's out from there.
You can say email to Padmakar.
Can you send email to Padmakar? You have email ID? Email ID? Padmakar?
Padmakar, yeah, sure, I can send us.
Yes, just send him.
Yeah.
He's here.
Oh.
Yes, please. Yeah. या मैं तो क्रोम ब्राउज़र से यूज किया था। ठीक है, मैं क्लोज करके फिर हाँ रीजॉइन कर दूँ। श्योर। नहीं एक्चुअली ना कुछ आ नहीं रहा।
Tell you to send the slide.
Send the slide now.
Okay, I will send the screenshot to Kaustav sir because he is there only.
तुम मेरा ईमेल में वो भेज दो, तुम्हारा प्रेजेंटेशन
भेज दो।
अच्छा प्रेजेंटेशन भेज
दो।
Tell him to send the
presentation.
He's sending. He's sending.
Hello. PPT. Send your PPT.
You are sending the PPT, right?
Okay, I'll send PPT to Padmakar sir.
You send me. किसी को भी भेजो. Send anybody.
Okay. Okay. Yeah, I'm sharing it to Padmakar.
हाँ. Padmakar. Have you sent Murli?
Sir, yes, sir. Take a little time because there is some video also. Just please hold.
Meantime, you can just check it with your browser. Hello.
Yeah. Yes, sir. I am checking it.
Which browser you are using?
Chrome only. Sorry, sir. Chrome browser I am using.
Okay, you have an application, Teams application. वो क्या
No.
problem. Sir.
उसको बोलो वीडियो मत भेजो पीपीटी भेज उसको बोलो कि वीडियो मत भेजो
पीपीटी के अंदर ही
Okay. You have any desk? I'll just do it from here.
Yeah, sure. I will open.
Yeah.
The index called.
I will share. Yeah, my. Hello.
हाँ हाँ आपका एड्रेस बोलिए.
48.
Just a minute, just a minute. हाँ बोलिए 48.
66.
हाँ.
Your presentation now. Okay.
Yeah, you tell him to finish in 10 minutes.
Achha, yeah, sir is telling to finish in 10 minutes, huh? Okay, so make it sure. Okay. Thank you.
Is audio
Sorry for the delay. There may be some issue with my browser. Okay. Good evening to all. Here I am going to present. Sir, am I audible?
Yeah. Go ahead.
Yeah. Here I am going to present some of the observations that we have taken during the monsoon 2022 at atmospheric research test bed, Central India. Can you change to next slide? Yeah, this slide shows the GPM IMD merged rainfall during the month of August 2022. So here the large scale features of monsoon are very clearly evident. Something like like a heavy rainfall in the monsoon trough zone has been well captured by the GPM IMD merged rainfall dataset. So even in this slide, we can able to see some of the extremely heavy or heavy rainfall events that have been occurred in the central India, especially in the Bhopal or Madhya Pradesh region. Can you go for next? Okay, yeah, this is one of the previous. Yeah, this is actually one of the extremely heavy rainfall event that have occurred in the central India, especially in the Madhya Pradesh, Bhopal region. So these large scale features has been well captured by the merged rainfall dataset. However, if you want to study the storm scale convective features, radar is the best suited to understand this storm scale feature. So we selected this RTCI Bhopal radar to understand the storm scale convective features during these extremely heavy rainfall cases occurred during the monsoon 2022. Please next. Yeah, this shows an overview of the RTCI observatory. Of course, the top topography map shows the location. I mean, the black dot shows the location of the RTCI radar, and right one is the C-band radar, which was installed on the top of the tower. Apart from this C-band radar, we have another other ground-based measurements like ceilometer, digitometer, radiometer, and micro-rain radar are also available at the observatory. Can you go for next? Yeah, during this monsoon 2022, we have observed a total 98 rain events. Among that, there are 20 heavy to extremely heavy rainfall events have been captured at the RTCI Bhopal site. So in the present study, we have considered 16 of these 20 extremely heavy rainfall cases because of there are some power fluctuations or power failures at the radar site. We could not able to get the data completely during the month of June. So here we have analyzed only 16 cases of the heavy to extremely heavy rainfall cases. Next. Yeah, this slide shows the total seasonal rain accumulation collected from the digitometer at the RTCI site. Here you can see there is nearly 1600 mm of rainfall have been occurred at the RTCI facility. Among that, there are several extremely or high rainfall events. You can see like some of the spikes kind of thing in the rain accumulation. These are the several spells of heavy to extremely heavy rainfall events. Next. Yeah, during this heavy rainfall events, if you look at the top one rain rate figure, So there are continuous rainfall, or maybe sometimes there is a maximum rain rate. You can able to see this corresponds to these heavy to extremely heavy rainfall cases. Can you go for next? Yeah, this is a radiometer observations during the monsoon 2022. As I said earlier, when there is a heavy to extremely heavy rainfall event occurred, at that time, like cloud liquid water or water vapor density is higher in the radiometer measurements. Can you go for next? Yeah, can you play the video? Actually, this is one of the typical example of heavy rainfall event that has been captured by the C-band dual pole radar at RCA. Here, there are cloud clusters are developing in the radar domain, which organized into well-organized convective storms, and they are propagating from east to west. This complete picture has been nicely captured by the radar. Can you go for next? Yeah, in this analysis, we have analyzed completely almost 1.5 lakhs of convective pixels to understand the storm scale convective features of the extremely heavy rainfall cases. This is one typical example of extremely heavy rainfall event that occurred on August 22nd. The top left shows the reflectivity map. So here you can see almost like a widespread convection, with reflectivity nearly 40 dBz. And the top right is the maximum reflectivity in the vertical column. That also shows, of course, the top and the right panel shows the storm height in the east-west and north-south directions. So you can see that the storm extended up to 8 kilometers in the vertical. And this, apart from this reflectivity, this radar can able to measure the dual pole parameters like differential reflectivity, correlation coefficient between horizontal and vertical polarizations, and specific differential phase. So by using these polarimetric products, we can understand the microphysical structure of the convective storms. Next. Yeah, here I have shown the vertical cross section of this same 22nd August rainfall event. So the left one is the reflectivity from the C-band radar, which shows that there is some kind of red band signature at about 5 kilometers. So indicating that this is like a stratiform rain event. And one more thing you can notice here is the top height is below 8 kilometers. That means the storm top confined to 8 kilometers only. And of course, the same thing you can able to see with the micro rain radar observations, which is the ground-based instrument. So the reflectivity is more or less matching. Maybe little intensity variations might be occur. That depends on the because of the instrumental error. And of course, if you see the top risdometer observation, a total of 230 mm of rainfall have been observed on that day within 24 hours. Next. Yeah. Here I have plotted the seasonal statistics of these 16 heavy rainfall events. The left one is the occurrence frequency of all these 16 heavy rainfall cases. So if you look at this clearly, the storm occurrence is nearly same entire radar domain. If you take from 0 to 100 or 150 kilometer radius, except there are small and high instances around -50 to +50 kilometer radius zone. The right one shows the storm area histogram, convective storm area. This shows that almost 60% of the convective storms have area less than 50 kilometers square, and about 80% of storms will have a convective area less than 100 kilometers square. This shows that these convective storms, majority of these convective storms are sub-MCS category. Their area is less than 100 kilometers square. So here comes the beauty of this weather radars, where we can able to see this sub-MCS category of convection. So to understand these convective features. Next. Yeah. The left plot shows the maximum reflectivity inside the vertical column. The histogram of that maximum reflectivity I have shown here. If you look at this one, the histogram peaks at 35 dBz reflectivity, indicating that the reflectivities are moderate in these 16 heavy rainfall cases. That means the the convective storms are not high intense, it is moderately intense. And if you look at the right histogram, that shows the height of the 35 dBc reflectivity, so which peaks at almost 5 kilometer height. So that indicates that the convective top is not deeper, so indicating that these kind storms are either shallow convective or cumulus congestus clouds during these 16 extremely heavy rainfall cases. Next. Yeah, this slide shows the horizontal and vertical extent of these convective storms during this extremely heavy rainfall cases. The left one shows the histogram of storm area versus maximum reflectivity. Like if you look at the storm area below 100 kilometers square, so the reflectivity is confined below 40 only. That means the whatever the sub-mesoscale MCS category storms, these are all having less like moderate intensity. As you increase the storm area, the intensity of the storms also increases, and of course it reaches a value of 40-45 dBz, like moderate to heavy intense convection takes place during this heavy rainfall cases. The right one shows the near surface reflectivity, which is a 2 kilometer reflectivity versus precipitation top height. We have considered the 18 dBz reflectivity as the precipitation top height or eco top height. So if you increase the near surface reflectivity, that means when the rain rate at the surface increases, the precipitation top height also increases. And of course, here you can able to see two modes of distribution. Can you press one more time? Next. Yeah. You can see here two modes of distribution for the precipitation top heights. One is confined below 8 kilometers or maybe around 8 kilometers, and another one is above 12 kilometers. This 8 kilometers convective top height shows the majority of the congestus or shallow cumulus clouds, whereas this about 12 kilometers shows the deeper or overshooting clouds. Next. Yeah. The diurnal variability has been analyzed for these 16 cases, and the diurnal variability shows that the storms, majority of the storms occur in the afternoon hours, and of course there is one more peak in the early morning hours. That means the diurnal variability shows a bimodal distribution, which is consistent with the earlier studies like Jha et al. 2022. They also observed this diurnal variability of bimodal distribution, diurnal variability over the central Indian region. The only difference between the earlier study and our study is the maybe intensity differences. This may be due to because in their study they have considered 13 years of TRIM data, TRMM rainfall data set, and they have considered all the convective storms. So that could be one of the reasons for their higher intensity in the convective peaks. Whereas in our case, we have considered the only extremely heavy or heavy rainfall cases only. So these are the storm scale convective features which we have observed with the C-band dual pole Doppler weather radar during the extremely heavy rainfall cases. We try to understand what are the majority of rainfall types that are present in these extremely or heavy rainfall cases. So this slide shows the different rain types. In these extremely heavy rainfall cases, we have categorized into like stratiform, convective, mixed stratiform convective, and isolated convective shells. And this shows the spatial distribution of these different types of rainfall categories. So you can see here the majority of the storms here is stratiform in nature. And of course, there are less occurrence of other modes. You can see the difference in the color bar. The mixed stratiform convective is dominating second dominating one. And of course, the convective is slightly distributed throughout the entire radar domain. Yeah, next. To summarize this, so this RCI, we have collected almost 1600 mm of rainfall in this monsoon. And in the radar domain, the dominance of shallow convective storms or cumulus congestus is observed. The heavy to extremely heavy rainfall is associated with moderately intense storms. Whereas the storms associated with this heavy rainfall are sub-mesoscale to mesoscale convective system categories. However, the majority is sub-MCS category only. The diurnal storm occurrence shows a bimodal distribution with primary peak in the afternoon hours. And of course, the stratiform rain is contributing more towards this extremely heavy rainfall events. Next. Yeah, at the outset, I would like to thank all the team members of this RCA who are working together to collect these data. Of course, right from the beginning. Until now, the campaign is going. We are collecting 24/7 observations, and of course, they are taking observations. So, of course, this photograph is taken during the visit of Joint Secretary MOES. So, yeah, I'd like to thank everyone. Thank you.
Can I ask one? Yeah, sure. Yeah. Very nice talk. Can you please explain why most of the storms are concentrated near the center of the radar? Yes.
Yeah, actually, can you open my slides? Can you go back? Back. Slide number 8. Yeah. Here, if you look at the column max Z reflectivity or reflectivity plot, so majority of these storms are occurring at the that region. Of course, I could not comment anything on this as of now because we have analyzed only several cases of extremely heavy rainfall events. Suppose if you can understand, if you can study the whole seasonal data, then you may comment on this thing. But time being, majority of the storms what we have observed are confined near in that zone only, like plus or minus 100 kilometer radius from the radar. That is one. That could be one reason. And other thing is can you go to slide number 11? Sir, 10. Yeah, here that whatever you are maybe saying that outer region that less storms are occurring. That could be because of suppose even if you take the radar beam at 0.5 degree or 1 degree. So at around 150 kilometer, the beam will encounter. I mean, it will be about 2 kilometers. So some of the storms might be missing in that cases. So beyond 150 or 200 kilometers, the occurrence frequency may be less. That is another thing.
So but there,
the second
range is 200, right?
200, but for
what
storm
is the
identification,
range of the radar is
2 kilometers. Your beam will go like this.
Yeah.
So it will
What is the range of the radar?
250 kilometers.
So beyond 250, what is happening, you don't know, right?
Yeah.
So see, monsoon is not a localized system; it's a propagating system, right? The convection doesn't remain stationary at one point. It's coming all the way associated with the southwest corner of monsoon depressions right from the head Bay of Bengal and propagating, right? You are able to see when it comes in the radar domain.
So yeah, what it suggests, the radar has the same 1.5 degree. So it is going like this.
Yeah.
So it will not see the cloud bases or the storms at a far away. So it is showing more storms near the because
Earth curvature. Ideally, you should have 1 kilometer. Yeah, that's what. Anyway, it's good.
Yeah, it's very good.
It's a pond. You are looking at a pond. You should not
Solid
Murali, very nice presentation. I have one question regarding how did you identify the extreme rainfall? On which basis? Is it from the distrometer that you have on at the site?
Yes, ma'am. Actually, IMD has given definition for different categories of rain. They have classified different rainfall categories depending upon the 24-hour accumulated rainfall starting from 8:30 to 8:30 of the next day. So depending upon that, we have categorized these storms into different categories. Like among that, we have selected 16 cases of heavy to extremely heavy rainfall events.
Yeah, that is actually, you may also look at the spatial, derive the rainfall estimates and maybe consider only 100 by 100 kilometers.
Yeah, ma'am. Actually, I just want to add this thing. We have even analyzed this IMD GPM merged rainfall data set. So whatever the thing, both it look, I mean, like it should have the same category. It should satisfy the category from that GPM IMD merged rainfall data, the spatial as well as at the site disdrometer observations. Whenever it matches, those cases only we have selected. It is not like that only point observation we have considered here.
So, but yeah, I have one question, Dr. Murli.
Yes,
Is
sir.
IMD GPM Mars data is a graded data, correct?
Yes, sir.
What is the resolution?
Point 1.
0.1 or 0.2, right? 0.25. 0.1. So it is actually 0.1 by 0.1. So 10 by 10 roughly. It's 100 square kilometer mean rainfall. Okay. So it will actually, if you take a point station rainfall, you will find graded rainfall will not match.
Yes, sir.
Not match. And I can tell you, we have analyzed. If you see that the IMD's climate bulletin, what they have published, okay, the number of extreme event what they count, they don't count it from Mars data. They actually count from the station data. Because if you count, using Mars data, the number of extreme will be completely different from what they are getting from the station data. So, but when you are stationed at one point, it is always better to consider the station data, not the Mars data.
Can I add?
Yeah, actually, sir, even we have analyzed this GPM rainfall IMERGE data set also in our 2017 paper. So this GPM more or less matches well with the ground-based observations. What you are saying is exactly correct.
It will be randomly matched. There is no reason. I don't find any reason that a graded mean rain suddenly will match with one station data. It should not match.
Can you go
No,
to that IMERGE data set from where we show that table? Okay. So you just see that definition. So
this definition I know.
Yeah. So based on that accumulation, we have.
No. My point is, this is okay. This is IMD's criteria is fine. Yeah. This criteria itself has hundreds of questions. We can question this criteria itself. Let us not go into that. What I am trying to tell is, please listen. See, this 64.5 to 115.5. This is a category defined by IMD for heavy rainfall, 6.5 centimeter to 11.5 centimeter at one point. Okay. But in the, whether you take IMERGE, you take GPM, you take TRIM, you take any dam graded data in the whole world, it will give you a grid mean. Okay. Now, how can I compare a grid mean data with the station data?
No, we are not comparing. Actually, if you consider this accumulation,
yes,
it's crossing that accumulation. So based on that, you have to consider that extreme events.
No, that's fine. No. So don't bring IMD GPM at all.
No.
This is for special information. So he used the ground-based distributor.
You tell that I am using IMD criteria.
Yeah. IMD criteria is
you tell I am using IMD criteria, but using station data.
It is for identifying the event.
That's fine. Don't bring graded data.
No, sir. I will tell you. Another question will come. How 250 by 250 kilometer of radar is a representative of one disdrometer?
Because it is possible. It is possible if you are in a homogeneous plane, like atmospheric radiation measurement in southern Great Plain. It's a homogeneous plane. If you have that homogeneity in your site, you can. Your one radiation observation, one instability, one soil moisture can be. That's why we have gone to atmospheric, art. So there was a huge brainstorming. Why should we go to Bhopal?
This is not just based on the IMD data. He has used the disdrometer data also.
That's fine.
You see the rainfall accumulation, and these 16 days belongs to those.
My point is, single point, any data you use, no problem.
This is based on single data and with
No
the
problem.
criteria of IMD data.
That's fine. See, I tell you, so that's fine.
Yeah, they also redefine this.
Yeah.
Okay, I think very nice talk, Dr. Krishna.
Thank you.
What you have done is really impressive.
This is very good. Yeah.
Yeah,
Very nice.
Overall, all the presentations were good. And if anybody has.
So coming back to this large scale, two, three things what I feel, which is well presented. One thing is the northwest Pacific, all the systems, tropical cyclone systems, synoptic systems, northward curvature. That is the one thing. Another thing is northward. You can see that. I mean, most of the systems.
Some went northward.
Most of the system you can see. Very few went westward.
Who presented that somebody?
Most of the
Westward.
Most of them have the curvature.
You can see that. The second thing is Bay of Bengal convection also. Bay of Bengal systems. Bay of Bengal system. I am just comparing with 2010. So Bay of Bengal systems also this time. I mean more than four systems, 4 depressions were there. And another thing is the shift of this monsoon trough. That is one thing is very prominent. Shift of westward shift. We can say.
Southward shift of trough.
Yeah. West shift of the. Yeah, westward shift. I will say.
Westward shift of rain. Southward shift of.
So these things are very prominent.
But among so many slides, how did you pick up the typhoon slide?
That is very.
He elaborated with his.
No, ask the audience.
That is very true. Now, if you see the 2010 case, I mean, westward shift of large scale, this West Pacific tropical, this West Pacific subtropical high, that was a very, main feature during 2010 La Nina. 2010 La Nina, if you see, the rainfall was, was almost close to normal, but Bay of Bengal convection was totally suppressed. Totally suppressed. There was not a single system evolved in Bay of Bengal during 2010 monsoon. So that was one thing, and it's this shift also, large scale shift of the circulation. Indo-Pacific region and the this monsoon trough also. That was also, it's a northwestward. What Pakistan floods. So this year also what we saw the Pakistan floods, but this year Pakistan flood may have more severe, but more influence from the extratropical winds. That also, that cannot be. Yeah, that was there, but this year it may be more prominent.
Arabian Sea.
Yes. 2010 Arabian Sea contribution was, but Pakistan Meteorological Department, they don't believe.
So the take home message, we should revisit 2010.
Yes. Yes,
this year. Yeah.
So you are saying Bay of Bengal is active. This is actively, it can come there also. Rest of propagation or less. Because that very few.
Should involve him in.
Again, you can see that, but very true. This year, July, I think tropical cyclone was not there during the West Pacific. Tropical cyclone was
June it was not there, but
July, August is there.
August it was. But West Pacific was not that active. That is very true this year.
But we did not much discuss about the Pakistan flood. Anybody? Srijit, what's your take? Pakistan flood in stationary low. No, forget model. Just tell about the large scale.
Mainly that is interaction with monsoon depression as well as the western disturbance. And another thing is that there are many snow melt because of that also.
That's what they are saying. The flooding.
That also caused severe injuries.
Prashant, June initial condition. You had some session for June.
Yes.
Can you show that?
so far we were discussing why we got on. Now
I think there is something there. It is not.
1 month's forecast.
This is a monthly distribution, sir. June.
July.
Some deficiency here for July as.
Not this one.
Actually, total.
No, that is not deficiency. Yeah.
Not much deficiency. Total.
Yeah. For total use.
Yeah, this is the total. July, August, September. The total.
Yeah. So you are getting, see, correctly you are getting the.
No, Northeast. Not much.
Not so much, but yeah.
This extension is not there.
Yeah, only a blob over.
Model में इतना थोड़ी कंप्लीट था मॉडल में इतना थोड़ी
Some signal, but signal is there. Yeah, some
signal is there. Yeah, maybe this plot you make it big, slightly over a bigger region.
Sure.
This is only July or July, August,
September? July, August, September. 3 months August.
Next one is July, August, September.
August, September, October.
Yeah.
And what is that the right side?
This is August, September, October. Next 3 months.
No, there is another next one. Next slide. There you are showing.
Yeah. Next slide, I just made the monthly.
Yeah. This is July, August, September.
July, August, and September.
Yeah. Whatever you are getting is coming from July.
Yeah, it's only from June.
Why July is better?
Total.
Maybe question.
Partha, what about that heavy rainfall in your short range forecast in Pakistan? Did you see that?
Yeah, actually, we cut the all our analysis. It's not good, but we can just extend it. It's, yeah. I mean, we can just expand the analysis. The data is there.
I can make we wanted to see.
I think there are some interesting things that the model is getting. It is not.
No, the model is getting in spite of planning. That is why it is worth analyzing.
Yeah, actually, sir, we did when we have a Ramos paper, we did that subdivision-wise analysis for CFS. But every subdivision, same relationship with the ENSO. So if you see in observation, all the subdivision has
all are equal.
Yeah, all are equal. So if in that, if it is getting difference, it is something is capturing.
No, but question is, yeah, in the question to Raju also, suddenly Northeast you showed a very good skill, right? No, suddenly only. All model has bad skill for Northeast and Southern Peninsula, right? So that's a point actually, why it is happening. You know, yeah, there from there only your paper will start. For example, here, July we got, as director is telling, signal is correct, but why that signal didn't persist in August and September? So what's that magic happened in July and that magic vanished in August and September? That's where we learned. I mean, that Seelan was telling, what are we learning? This is how we learn. There is no other way.
July is not able to capture.
I am not getting into IC jargon. Once you enter into IC, you are lost.
You are saying that December 18, it is still is good. But in the Northeast, it is not a bit.
In longer.
Maybe something like that. If you start from a break condition, there may be skill maybe more. That can also happen because June was a deficit time, so we have a better
sensitivity.
The other one is a 5.3.
CFS V3. But that we also don't know because we have not seen July.
It is not full. It is just April. Only hindcast complete.
Yeah, I think Ramesh Yadav wins.
Yes, look at that.
He's in his own word.
Some of those schematic that's really happening like this. There is an equal road from Atlantic and Pacific. But the models are too sensitive to Pacific. And the Pacific is also here very
playing a role.
favorably acting. The model is only responding to Pacific. It is suppressing the other.
Have you seen to analyze the Tibetan anti-cyclone intensity has increased or decreased? See, from the actual model of forecast or observation.
That is what I told him to see that when he approached them also, but then IMD, I mean, they are not storing the data.
Who is not storing?
Many all data stored.
I will show my.
Really, who? From where you got the mail? कहाँ से mail मिला?
He tried to get the data. He said, I got the reply.
You must have written to wrong person.
Observation में किसी का पूछा होगा.
He will not touch model. I like this.
No, that is not.
Bhajan sir, ये 2010 में June deficit था क्या? June deficit and other months are excess, something like that. Or every month is same.
Really, sure. Ask the students whether they have any questions.
Yeah.
There are big number they have come. Any questions from students? Yeah. Kusan. Mike,